and that's defaulted to 180 days. So I would probably leave that as on. And we can notify users on password reset, notify all admins when other admins reset their password. Very useful. This was probably turned off, so I'd go ahead and turn that on there. You can customize a help desk link. So the idea here is that when someone's having trouble, they might say, contact your administrator. Well, how do you contact the administrator? Well, you provide that information, either a URL or an email. So I've just provided my email there. There's some on-premise integrations. Never used this stuff before because I'm never working with on-prem. But that stuff is pretty straightforward as well. And then you have usage and insights. So you can actually see when people are resetting their passwords and things like that and what is being used. So that seems pretty darn good, but that's pretty much it to it. Yeah, so there you go. Hey, this is Andrew Brown from Exam Pro, and we're looking at the Azure Active Directory cheat sheet. This one's 3 pages long, so get ready for it, and let's jump into it. So Active Directory, just Active Directory alone, which is AD, is Microsoft's identity and access management service, helps your employees sign in and access resources. Then you have Azure AD, and this is the same thing, except it's the cloud-based version. And one term that you'll hear a lot with this is identity as a service, which just means that it's like the serverless or hosted version of this, so you don't have to think about it or manage servers. Azure Active Directory comes into 4 editions. You got the free one, the Office 365 apps, Premium 1, which is also known as P1, Premium 2, which is P2. It's good to know the differences between what features you have here, so you should know all the details in between here. So I highlighted conditional access because that's an important one on the exam to know. Azure AD can authorize and authenticate to multiple sources. So if you're doing on-prem, you're going to be using Azure AD Connect. If it's for a web app, you're using app registration. If you're using Facebook or Google, you're using external identities. If you're, you can also connect to Office 365 or Azure Microsoft, okay? For Active Directory terminologies, when we're talking about a domain is an area of network organized by a single authentication database. An Active Directory domain is a logical grouping of AD objects on a network. Then you have domain controller, commonly abbreviated as DC. Domain controller is a server that authenticates user identities and authorizes their access to resources. You have a domain computer, a computer that is registered with a central authentication database. A domain computer would be an AD object. Then you have AD objects. That just is the base element of Active Directory things like users, groups, printers, etc. You have a GPO. This is a virtual collection of policy settings. Then you have organizational units. This is a subdivision of your AD, which you can place users, groups, computers, etc. in. You have directory service, such as Active Directory Domain Service, ADDS, which provides a method of storing directory data and making the data available to network users. A directory service can run on a domain controller. That's only page 1. We're on to page 2. So a tenant represents an organization. A tenant is dedicated is a dedicated Azure AD service instance. A tenant is automatically created when you first sign up either with Microsoft Azure, Intune, or 365. Each AD tenant is distinct and separate from other tenants. When you perform a lift and shift of AD to Azure, not all the features are supported. In that case, you're going to be using ADDS. So ADDS provides managed domain services such as domain joins, group policies, lightweight directory access, and I never can say that word, so I'm not even going to try. Azure AD Connect has the following features. It has password hash synchronization, pass-through authentication, federation integration, synchronization, health monitoring. You've got the concept of users, so that's an AD object, remember? So an identity of a person or employee in your domain, a user has login credentials and can use them to log into the Azure portal. Azure AD has 2 kinds of users. We got a user that belongs to your organization and guest users, a user that belongs to a different organization. Groups let resource owners assign a set of access permissions to all the members of the group instead of having to provide the rights one by one. And the group contains owners and it contains members. Just a moment here. There we go. Just want to make sure I'm recording the video so I don't end up finding halfway I didn't do it. So we got assignments. So you can assign roles directly to a group and you can assign applications directly to a group. We're on to the last slide here in the cheat sheet. Told you this one was long. Request to join groups. The group owner can let users find their own group to join instead of assigning them. The owner can also set the group to automatically accept all the users or join to require approval. There are 4 ways to assign resource access rights to your users: direct assignment, group assignment, rule-based assignment, external authority assignment. Know all 4 of these, please. And so, yeah, there we go. We're at the end here, and that's all there is. So let's take a look at the type of Azure roles. And I was honestly first confused with Azure roles because I'm from AWS and we only have one kind of role, but Azure happens to have three kinds, and there's definitely good reason for it. So let's break that down. And the first one is Classic Subscription Administrative roles. And this is the original role system. Now, it's not something you're going to be really using, but you should know about it because it still does exist. Then you have Azure Roles. This is the authorization system known as Role-Based Access Controls, or RBAC, and it's built on top of Azure's Resource Manager. And then thirdly, we have Azure Active Directory, also known as Azure AD Roles. And these Azure AD roles are used to manage Azure AD resources in a directory. So let's jump into it. So let's first talk about access controls, or IAM. So IAM stands for Identity Access Management. It allows you to create and assign roles to users. And so this is the general interface for IAM in Azure. And so we're going to have Azure Roles, which is part of that role-based access system. And so roles restrict access to resource actions known as operations. And there's two types of roles for the Azure role-based access system. You have built-in role. So this is managed by Microsoft, and they are read-only, and they're pre-created roles for you to use. And then we have custom roles, and these are a role created by you with custom logic. And so the place you're going to find it there is you're going to see it says roles right there. And that's what we're looking at down below, is a bunch of roles. So you see owner, contributor, reader. Those are predefined roles for you. And so then you have role assignment. And this is when you apply a role to either a service principal, a user group, a user. And so that's going to be under the tab there. So that's just you applying a role to somebody. And then you have deny assignment. So these block users from performing specific actions, even if a role assignment grants them access. And the only way to apply a deny assignment is through Azure Blueprint. So this is just something where you're just setting up like guardrails to make sure that certain things are never used, regardless if a role is applied. So now let's take a look at classic administrators. And this is the original role system. And you honestly want to be using the new RBAC system whenever possible. But the idea here is that you're going to go, it's in the same place that we just saw the access control. And there's a tab called Classic Administrator. And in there, you can set up administrators here. And so you have three types of roles. You have the account administrator. This is the billing owner of the subscription and has no access to the Azure portal. You have the service administrator. So this is the same access of a user assigned the owner role at the subscription scope, and they have full access to Azure portal. And then you have the co-administrator. So this is the same access of a user who is assigned to the owner role at the subscription scope. So it's those very three simple roles. And we actually have one because when Beka, who's the other Andrew, set up our Azure account, I think it just sets you up one. So even though you're not really going to be using it, I do believe that it still sets you up one when you make your account. So that's just what it is, but there you go. So let's take a closer look here at Azure role-based access controls, because this is something we're definitely going to be using a lot. And so role-based access control helps you manage who has access to Azure resources, what they can do with those resources, and what areas they have access to. And the idea is that you have a user and you want to assign them a role, so you're going to use a role assignment. And a role assignment is made up of three elements. You have the security principal, the role definition, and the scope. And we're going to look at those three things in a little bit more detail here in a second. And there are four fundamental Azure roles, which we are going to learn. And then Azure RBAC also includes over 70 built-in roles, which we definitely do not need to go into great detail. So let's take a look at one of those three elements first, which is the security principal. And this represents the identity requesting access to an Azure resource. And when we say identity, that's just like a loose term for something. And that something could be a user in your Azure Active Directory, a group, which defines a set of users in your Azure Active Directory, a service principal, so a security identity used by applications or services to access specified Azure resources, or a managed identity, an identity in your Azure Active Directory that is automatically managed by Azure. So service principal is basically an Azure service, and then managed identity is something in your Azure Active Directory. Then we'll move on to scope, and a scope is just a set of resources that assess the role assignment applies to. And so scope acts as controls at the management, subscription, or resource group level. So what does that mean? And we have another slide on this. I can't remember what section it's in, but you have this breakdown of scope where you have management groups, subscriptions, resource groups, or resources. So when you're saying I'm setting a scope, you're saying what is the scope? Is it on a management group? Is it on a particular resource? Is it a resource group? And that's what we're trying to say there. And then the last element there is a role definition, and this is a collection of permissions. So a role definition lists operations that can be performed, such as read, write, and delete. And roles can be high level, like owner specific, or like a virtual machine reader. And so Azure has built-in roles, and we said there were 4 fundamental built-in roles, and here they are. It's owner, contributor, reader, and user admin administrator. So you want to know those 4. And then across the board, you have those 3 operations: read, grant, and then create, update, delete. So you can see the owner can do everything. The contributor can both read and create stuff, but they just can't grant access to other people. The reader just has read-only access. And then a user access administrator is granting other users privileges, but themselves are not creating anything. All right? So now let's take a look at the third type of roles, and that's Azure AD roles. And so Azure AD roles are used to manage Azure AD resources in the directory, such as creating or editing users, assigning administrative roles to others, resetting user passwords, managing user licenses, and managing domains. And so on the right-hand side here, what we can do is go into Azure Active Directory in Azure, and under roles and administrators, we can see there is a bunch of roles predefined for us, like application administrator, application developer, etc. There's a lot in there. And a few important built-in roles that you should know is the global administrator. So this gives you full access to everything. The user administrator, full access to create and manage users. The billing administrator makes purchases, manage subscriptions, and support tickets. And I want you to know that you can create your own custom roles, but for whatever reason, you have to purchase this. This to me is a bit unusual because in the AWS world, this is something you don't have to pay for. But I guess Azure Active Directory has been around for a long time. And so they have this whole big tier in there. And so if you want to be able to make custom roles, you have to upgrade your Azure AD to Premium. So Premium could be P1 or P2. And I'm assuming the higher the number, the more controls, okay? So let's take a look at the anatomy of an Azure role. And as you saw in the previous slide, it does cost money to be able to have the privilege to create custom roles. You'd need an Active Directory Premium version 1 or 2. But it's still a good practice to go take a look at what the contents of an actual role is, because you can actually look at the managed roles, open them up, and see what they do. And you should really look at them and not just take them based on the face value of the name of the role. So I want you to know that Azure role documents have 2 different syntaxes, whether you're using PowerShell or CLI. And so for the example here on the right-hand side is going to be using PowerShell. And it's very simple. And it's just the property name is going to change. So see where it says name? If you were using PowerShell, I have in parentheses, it'd be role name. Okay. So if you look one up and it's using JSON and the names are different, you're going to have to do that translation. All right. So let's just quickly go through the properties here. So the first thing is the name. That's going to describe what the role is. Then you have the ID. This is not something that you are creating. It's going to be auto-generated for you. Then you have is custom, whether it's going to be custom or not. The description, that's self-explanatory. And then the actions. This is what you care about because the actions tell you exactly what you're allowed to perform. So that's a big list there. It's pretty self-explanatory. But then you have not actions. And this is basically you explicitly saying you're not allowed to do these things. It's just a guardrail to make things safe. Do you really need a not actions? I don't know. That's just how they designed it. Then you have data actions. This is an array of strings that specifies data operations that are allowed to be performed within the data within that object. And then you have not data actions, so things you're not allowed to do with data. And then assignable scopes. And this is an array of strings that specify the scope for the custom role. And you can only define one management group for assignable scopes for a custom role. I do want to just point out one other things with these roles, and it really just has to do with these asterisks. Just if you're not familiar with them, but that usually indicates a wildcard permission. It's like saying match everything. And so when you're doing that, it's going to match things like you can use it in actions, not actions, data actions, and not data actions. And so, again, it just matches everything in that sub thing because you might have a bunch of options you can put there. And so, for example, what it's doing, like let's see, you see where it says management or cost management, and it has action, read, write, delete, run action. All that stuff in red would be matched with that asterisk. And I know it doesn't match the examples on the right-hand side, but you just got to imagine that there's other things there, okay? Now let's just do a quick comparison between Azure policies and Azure roles, just to make sure that we're very clear what the difference of these two things are. So Azure policies, these are used to ensure compliance of resources. And Azure roles, these are used to control access to Azure resources. So on the policy side, these are going to evaluate the state by examining properties on the resources that are represented in Resource Manager and properties of some resource providers. They do not restrict actions, and we call this operations. Ensures that resource state is compliant to your business rules without concern for who made change or who has permission to make the change. Even if an individual has access to perform an action, if the result is a non-compliant resource, Azure policy still blocks the create or update actions there, okay? On the role side, it's very simple. It focuses on managing user actions at different scopes, and it does restrictions. It does apply restrictions on Azure resources, okay? So Azure resource or Azure roles controls what you have access to. Azure policies ensures compliancy. All right, just another comparison here. I want to compare Azure AD roles to the Azure roles, the RBAC versions. So AD roles, they are used to control access to AD resources, and Azure roles control access to Azure resources. And here's a good representation here, where you have AD roles on the left-hand side and Azure roles on the right-hand side. And the idea on the left-hand side, that actually represents like Office 365, but you can see Azure AD has some coverage both inside and outside of Azure. So an AD resource could be something like users, groups, billing, licensing, application registration, or etc. And then on the right-hand side for Azure resources, this could be virtual machines, databases, cloud storage, cloud networking, and etc. By default, Azure roles and Azure AD roles do not span Azure and Azure AD. And by default, the global administrator doesn't have access to Azure resources. So that's just good to know. And global administrators can gain access to Azure resources if granted the user access administrator role, so the Azure role. So there you go. Hey, this is Andrew Brown from Exam Pro, and we are looking at the Azure Roles cheat sheet. And when we say Azure Roles cheat sheet, we're actually talking about all the roles, not just the Azure roles, okay? Because there's three types. You got the classic subscription administrator roles. You have Azure Roles, which is also known as role-based access controls, that's built on top of ARM. And then you have Azure Active Directory roles, okay? So you need to know the difference between the three. When we're talking about Identity Access Management, IAM, that allows you to create and assign Azure roles to users. Roles restrict access to resource actions, also known as operations. There's two types of roles. You got built-in roles. Managed Microsoft roles are read-only, pre-created roles for you to use. And then you have custom roles, a role created by you with your own custom logic. For a role assignment is when you apply a role to a user, and a role assignment is composed of a security principle, role definition, and scope. Azure's four built-in roles are owner, contributor, reader, and user access administrator. I don't have the table here, but you should know the difference between them, but usually they're pretty self-explanatory based on their name. For classic administrators, we have three types of roles. We got account administrator, service administrator, and co-administrator. For important Azure AD roles, you need to remember you have global administrator, user administrator, billing administrator, and on the exam, you might even see more kinds there. So I would encourage you to go look up all the different kinds, or I might end up making a video going in more in depth for some of them in this course. You can create custom Azure AD roles, but you're going to need that P1 or P2. So there you go. That's Azure roles. Hey, this is Andrew Brown from Exam Pro, and we are taking a look at Azure Key Vault. So this helps you safeguard cryptographic keys and other secrets used by cloud apps and services. Azure Key Vault focuses on three things. So the first is certificate management. So easily provision, manage, and deploy public and private SSL certificates for use with Azure and internal connected resources. Key management, so create and control the encryption keys used to encrypt your data. Secrets management, store and tightly control access to tokens, passwords, certificates, API keys, and other secrets. And certificates contain key pairs, key and secret, not to be confused with key management and secrets management. I do have to list that out here because you'll notice here, and I'm getting my pen tool out, we have certificates, keys, and secrets. But within a certificate, it can contain keys and secrets. But just understand that there are three isolate offerings that Azure Key Vault has. If this was another provider such as AWS, these would all be isolate services. But a common pattern with Azure is they like to group a bunch of functionality under a single service, and so these things, which should be three services, are actually under all Azure Key Vault. But there you go. Let's talk about hardware security modules and FIPS, because this is important for Azure Key Vault. So hardware security modules, also known as HSM, is a piece of hardware designed to store encryption keys. Here's an example of one called Gemalto. I'm not sure how to pronounce it, but the idea is that these are pieces of hardware that are extremely expensive but are extremely specialized for holding in keys in memory, not even writing them to disk, so that there's no chance of somebody stealing those keys if they were to take the device. And then there's the standard of FIPS, also known as the Federal Information Processing Standard. So this is a US and Canadian government standard that specifies the security requirements for cryptographic modules that protect sensitive information. And so HSMs are, they can be multi-tenant, and if they are, this is where we would be using FIPS 140-2 level 2 compliant. So you have multiple customers virtually isolated on a HSM device. That's kind of a way of sharing the cost of one of these very expensive machines. And then you have HSMs that are single tenant. So this is where if you need to maybe meet level 3 compliancy, where you have a single customer dedicated on a HSM. So there you go. Let's take a look at what a vault is for Azure Key Vault. So a vault stores secrets and keys that can be protected either by software or by FIPS 142 level 2 validated HSM, so an actual hardware security module. Azure Key Vault provides two types of containers: vaults, so this supports software and HSM backed keys, and then you have HSM pools, so only supports HSM backed keys. And to activate your HSM, you will need to provide a minimum of 3 RSA key pairs up to a maximum of 10. Specify the minimum number of keys required to decrypt the security domain, called a quorum. And one key thing you need to know is you do not choose the container on creation. You choose between standard and premium. When you choose premium and create RSA key pairs, you'll be able to begin to create HSM pools. Because when I was going through the follow-alongs, I was like, hey, where are these HSM pools? And so that's where I found out about these requirements. We're not going to do that because it's just really expensive to do and it's out of the scope of the exam. But if you are an organization and you're thinking about using HSMs, those are some of the requirements there, okay? All right, let us quickly talk about the Key Vault API. So it's a REST API for pragmatically managing Key Vault resources, allowing you to perform operations such as creating a key or secret, importing a key or secret, revoking a key or secret, deleting a key or secret, authorizing user or apps to access its keys or secrets, monitor and manage the key usage. So here's kind of a diagram, and the idea is that via the API, you'd use the CLI to access the API. It would go into your vault, and if you had a certificate there, a certificate could contain metadata, key, and secret, and you could operate on that kind of stuff there. So the Key Vault REST API supports 3 different types of authentication: managed identities, so identities managed by Azure AD. This is the recommended practice because it introduces the least amount of risk. Service principal and certificate, so this is where you use the certificate. Service principal and secret, where you have a user and secret key. So there you go. So when setting up our vault, we have some very interesting recovery options. And so I just want to give this a little bit more emphasis of these interesting things. And so here it is, soft delete days to retain deleted vaults and purge protection. So soft deletes allows you to recover or permanently delete a key vault and secrets for the duration of the retention period. It's enabled by default on creation. There is a way to not have soft defaults, and I think we discovered that during the follow along. I just can't remember this moment here. Not that it's super important. Mandatory retention period. And so the mandatory retention period prevents the permanent deletion of key vaults or secrets prior to the retention period elapse. So just keep them around just in case. Then you have purge protection. So when enabled, prevents secrets to be purged by users or Microsoft. So yeah, there you go. Let us take a look at pricing for Azure Key Vault. So it comes in two pricing tiers, standard and premium. So the key difference here is premium allows for both software and HMS protected keys, where standard does not have HMS protected keys. So let's just take a look at the pricing in particular. So for RSA 2048, that's the size of the key, bit keys, you're looking at a cost of 0.03 cents for 10,000 transactions. And that's the same thing for HSS protected keys if you have it enabled, with the exception that you have $1 per month per key. For advanced key types, so we're looking at RSA 3072, 4096, so longer ones, or ECC keys, we're looking at a greater cost here, so 15 cents per transactions. And you're going to still pay that 15 cents per transactions, but in the HSS protected, you're going to see that it's going to have this kind of tiered thing. So for the first 250 keys, it's $5. For the next range of keys from 251 to 1,500, it's $2.50. And it gets lower and lower with volume. So more keys, the more savings you'll have. Some other things here would be things like secret operations. And this is the same for both software and HSM. So there's no difference in cost here. But the idea here is that there's a cost for secret operations at 0.03 cents. For certificate renewal, it's $3 per request. And then we have managed Azure Storage account key rotation, $1 per renewal. Managed HSM pools is $3.20. This might vary in terms of price based on your region. But, you know, I'm just kind of want to show you that there is an additional cost for just the keys when you have HSM protected, okay? All right, we're taking a look at keys for Azure Key Vault. One of the three core offerings, one being keys, secrets, and certificates. Keys, we use it to encrypt things, utilizing with Azure services. So like if you need to encrypt Azure disks or apply it in a variety of things where we have encryption at rest, you know, it's useful for this because it'll just easily integrate with those Azure services. So when creating the key, there are three options. We have generate, so Azure will generate the key, import an existing RSA key, restore backup, so restore a key from backup. For keys that are generated by Azure, you can either use RSA or EC. Sometimes we see people say ECC, but in the UI they called it EC. RSA is an algorithm, and it's actually the combining of three names of cryptologists or the people that made the algorithm. And you'll see there's a few different lengths, 2048, 3072, 4096. That's the amount of bits. That's how long it is. Then you have ecliptic curve cryptography, and then it says P hyphen, and we have 256, 384, 521, 256K. I'm going to assume that also has to do with length. I don't know exactly how it translates over to bit size, but I'm sure that's similar. For keys generated by Azure, you can set an activation and expiration date. Probably a good practice because that forces you to rotate your keys after a period of time. You can create new versions of keys, so that's a cool benefit. You can download backups of keys. Backups can only be restored within the same Azure subscription and within Azure Key Vault. I think we do that in the follow along. So for premium vaults, you do have additional options for HSM, and it's not that fancy. It's just like RSA and EC are repeated here, but with hyphen HSM to specify it's going to the hardware security module. You can generate, you can import for the HSM. There are Microsoft managed keys, also known as MMK. These are keys managed by Microsoft that do not appear in your vault, and in most cases are used by the default for many Azure services. So even if you don't think you're using keys, you actually are. And so the way, if you're using like AWS, you actually do see them in a key management service, but Azure decides not to show them and just have it by default there for you. Customer managed keys, CMK, are keys you create in Azure Key Vault. You need to select a key from a vault for various services. So sometimes a customer managed means that the customer has imported cryptographic material. But when we're talking about Azure, when you generate or import a key, they consider that a CMK. And I'm pointing that out because, you know, I use other clouds like AWS and GCP. And for AWS, CMK indicates imported cryptographic material, not exactly how Azure describes it here. In order to use a key as Azure Service needs an identity within Azure AD, so for permission to access the key from the vault. For infrastructure encryption, this is sometimes an option by default. Azure encrypts storage accounts data at rest. Infrastructure encryption adds a second layer of encryption to your storage accounts data. And we'll talk about double encryption because I was like, what's double encryption? And so then I had to make some slides here for us, okay? All right, let's talk about double encryption. So if we're talking about storage accounts, there's this option called infrastructure encryption. So if we checkbox that on, this is encrypts storage account data at rest. Infrastructure encryption adds a second layer of encryption to your storage accounts data. We just said that in the last lecture here, but I'm just trying to cement that this is for storage accounts. For Azure disks, it's called double encryption. And so double encryption is where two or more independent layers of encryption are enabled to protect against compromises of one layer or of encryption. It's the same thing, but for one, they call it infrastructure encryption, and for the other, they call it double encryption. Confusing, I know, but it's the same thing, okay? Using two layers encryption mitigates threats that come with encryption data, of course. So I just feel like we're repeating ourselves 100 times here, but Microsoft has two-layered approach for data at rest and transit. So for data at rest, you have disk encryption using customer managed keys, and then you have the infrastructure encryption using platform managed keys. Data in transit, the transit encryption uses TLS 1.2. That is the latest standard. There was over the years, it went between SSL, TLS. It's back in TLS's court, with 1.2 being the most up to date. Additional layer of encryption provided at the infrastructure layer. So should you enable double encryption? Yes, and always, every time you have that opportunity, utilize it, okay? All right, let's take a look here at Azure Key Vault Secrets. So one of the three offerings that Azure Key Vault has, so secrets, keys, and certificates. Azure Key Vault provides secure storage of generic secrets such as passwords and database connection strings. So here's an example of the form. We have the name of the secret, the value, so pretty clear how that works. Key Vault APIs return and accept and return secret values as strings. Internally, Key Vault stores and manages secrets as a sequence of octets, so 8-bit bytes, with a maximum size of 25K bytes each. Yes, 25K, not 256. Key Vault Services doesn't provide semantics for secrets, accepts the data, encrypts it, stores it, and returns a secret ID, secret identifier, so an ID. For highly sensitive data, clients should consider an additional layer of protection for data, encrypting data using a separate protection key provided to storage in Key Vault is one example. Encryption data using separate protection keys. So I guess you could encrypt the data and then upload the encrypted material there. So I suppose that might be what they're suggesting. Key Vault also supports a content type field for secrets. So clients may specify the content type of a secret to assist in interpreting the secret data. When it's retrieved, a maximum length of this field is 255 characters. All secrets in your Key Vault are stored encrypted. Key Vault encrypts secrets at rest with a hierarchy of encryption keys. All keys in that hierarchy are protected by modules that are FIPS 140-2 compliant. The encryption leaf key of the key hierarchy is unique to each Key Vault. Encryption root key of the key hierarchy is unique to the security world. Protection levels varies between regions. And we're talking about China here. So China uses FIPS 140-2 level 1, and all the regions uses level 2 or higher. I apologize for that spelling mistake there. We can apply secret attributes alongside our secrets. And so we have EXP, that's the expiration time. We have NBF, not before, so default value is now, the time before which the secret data should be retrieved, enabled, whether the secret data can be retrieved. And we saw some of these options in the actual form itself. There are also other read-only attributes such for created and updated. I think I'm supposed to say updated there. In order to access secrets within your application code, you would use the Azure SDK as an example. So here we're importing the Key Vault secrets. This looks like C#. This is C# code, sure. Oh yeah, it says over here, .NET. Okay. And so we import Azure Identity, Key Vault secrets. We're defining our options here. So delay, max delay, retries. I don't think that really matters too much, but the idea is that we are providing a URI to the actual vault, and then we create our credentials, we create our client, and this example is just getting the secret. So we're not using this to insert a secret, but just to kind of grab it programmatically. You can also use the CLI. So we have AZ Key Vault secrets show, and I'm pretty sure that's what we are using during the follow along. But yeah, there you go. That's secrets. All right, we're taking a look here at X509 certificates. So before we can talk about those, we need to talk about what is public key infrastructure, also known as PKI. So PKI is a set of rules, policies, hardware, software, and procedures needed to create, manage, distribute, use, store, and revoke digital certificates and manage public key encryption. So if there's a cloud service that manages certificates, it's a PKI. So what is X509 certificates? It is a standard defined by the International Telecommunication Union, ITU, for public key certificates or certifications. So X509 certificates are used in many internet protocols, extremely commonly used with SSL TLS for HTTPS, signed and encrypted emails, code signing, and document signing. So a certificate contains an identity, so hostname, organization, or individual, a public key, so RSA, DSA, ECDA, etc. And then there's the idea of a certificate authority. So this is an entity that issues digital certificates. A CA, or certificate authority, acts as a trusted third party, trusted both by the subject owner of the certificate and by the party relying upon the certificate. So there you go. All right, let's talk about chain of trust for 509 certificates. So a certificate authority, CA, can issue multiple certificates in the form of a tree structure, also known as a chain of trust. So here is an example for the exampro.co website. This was issued by Amazon. And so Amazon is the root authority here. And then they have their intermediate certificate, which issues us the certificate that is used for our HTTPS TLS communication to keep encryption in transit to the website. Let's talk about what a root certificate or root certificate authority is. So the root CA is a self-signed certificate, and its private key is used to sign other certificates. So when they're talking about self-signed, it just means that they've generated a key and they've done it on their machine there. And that's what they mean by self-signed, because they're not reaching out to anybody else in order to say that the certificate is valid. It's important that the private key of the root are protected. So like these are the most important keys, and to protect them, that's why we have this intermediate certificate authority. Also, we like to call these ICAs. So intermediate certificates are signed by the root private key and act as entities that can issue certificates. They protect the root certificate because the root certificate does not have to sign every issued certificate. Then you have your end entry certificate. These are the ones that we're going to be using. So a certificate issued by the ICA used by the end entity. The entity in the case of an SSL certificate for a website. So SSL, TLS. It's just common to say SSL, even though TLS 1.2 is the common standard when we were making the videos here. But there you go. All right, so we're taking a look at the certificate format. So here is the certificate information for the exampro.co certificate that we used for HTTPS for the data in transit to make sure that our information is secure. And if you open it up, you can see there's a bunch of metadata. And so let's talk about what's in here. So we have the version number. The version number is indicating that it's an X509 standard. Notice here it says 3, so we're using version 3. We have a serial number, a unique serial number assigned to the certificate by the certificate authority. So it's this big long thing here. We have the certificate algorithm ID used to sign the certificate. Could be RSA, DSA. In this case, is suggesting that it is RSA 250 with SHA 256 with RSA. The issuer, so the name of the certificate authority that issued the certificate to. So that's the issuer name up here. But this one is saying organization Amazon, things like that. So it doesn't say my name. Might be down below here somewhere. I don't see my name in here, but there's something here. Validity period. So how long is this certificate going to be valid for? The start and end date. The subject. That's what we want. The issuer would be Amazon because that's who it is. I guess I was looking for the subject. So the subject is who it is to be issued to. So that's where we'd want to see Exam Pro, but it gets cut off here, so we just can't see it. The subject public key, so the public key that is meant to be authenticated by the certificate. So this field is also names the algorithm used for the public key generation. Then we have other fields like issue unique identifier, subject unique identifier, extensions, which allow you to associate private information to a certificate. But the clear thing to understand is that all this metadata is publicly readable, so anyone can generally view it. That's the purpose of that is so that we can have the means to validate the authenticity of these certificates. So let's just talk about some things that can package along with the certificate so that there are ways of validating it. So we have this metadata, and this metadata gets produced in a hash. A hash is a means of taking a bunch of information and basically turning it into a thing that looks like a bunch of random characters, but it actually is a fingerprint because that hash, if you take the same information, it'll always produce the exact same hash. So it is a fingerprint to identify the information. So, that's that there. That hash or fingerprint is going to then get signed with the private key that is generated by the certificate authority, and that way it guarantees the authenticity of that fingerprint. And then the idea is that when you are signing that hash, it's basically creating a signature. Okay, so that's that authenticity. When you sign it, it's valid. So the certificate metadata, the signature, and then the public key provided by the end user is packaged there. And with all that information, we have enough information in order to validate the authenticity of the certificate. Okay. All right, let's take a look at the extension name for digital certificates because it can be .crt, CR, PEM, PER, DIR. There's so many varieties. It's very confusing. So let's see if we can unpack some of the complicated history here and make it a little bit more clear. So we have the first is PEM, so Privacy Enhanced Mail. And the idea of this format is that it's base64 ASCII. You can open them up, and they're very easy to read, very easy to edit. And it's the most common format for X509 certificates and for certificate signing requests and cryptographic keys. So the PEM format normally have the following extensions: CRT, PEM, CER, and key specifically for private keys. But there's no hard rule about it. So just because something is PEM doesn't mean it's going to end with .PEM. Then you have distinguish encoding rules. So DIR, this is a binary encoding. So if you open up the file, it's a bunch of binary code. You won't be able to make sense of it, edit it, do anything with it. It's used for both X509 certificates and private keys. DIR normally have the following extensions. So DER, CER. Then there are certificate files. That's where we have CER and CRT. These are base64 ASCII. So they're basically, I think they're basically PEM. And CER and CRTs are interchangeable extensions. So you can either have, they basically stand for certificate file, right? So that's what it's saying. So it's like, hey, CER is a short form certificate file. CRT is a short form certificate file, right? So that's where they get confusing. So either CER or CRT, these are generic file extensions. Then you have the Personal Information Exchange, PFX. This is a Microsoft certificate format. This is the successor. So PKCS #12 is the successor PFX. And so PKCS-12 will use either .P12 or PFX extensions. So there is a lot of confusion about the variety of formats. And it's just because there was a lack of standardizations early on. And so everybody was just trying to create their own formats or their own keys, and they weren't being consistent. And that's why we just end up with all these weird naming conventions. So half the time you cannot tell what something is. You have to open the contents of it. You have to know what you're using it for. And just, just be aware that it is confusing. Even for me, I've been doing it for like, 20 years, and I still can't tell what's what. So that's just what it is, okay? Hey, this is Andrew Brown from Exam Pro, and we are taking a look at certificate signing requests, also known as CSR, is a message sent from an application to a registration, so a certificate authority, of a private key infrastructure in order to apply for a digital identity certificate. The most common time you would deal with a certificate signing request is when you need a SSL TLS certificate so that your website has HTTPS, so it's data in transit. So the idea is you would submit a certificate signing request to your certificate authority. So like if you're getting your certificate from GoDaddy, Amazon, I'm thinking of GoDaddy actually has certificates, but like GeoTrust site or something, you have to submit a CSR. So a CSR contains a public key and application information such as a fully qualified domain name, because like if you're getting a CSR for domain name, they're going to need to know the domain name. And so that's the two things that get packaged together. So the idea is you create your certificate signing request, you request the certificate to the certificate authority. The certificate authority will issue you a certificate if it deems that it likes your request. But there you go. Hey, this is Andrew Brown from Exam Pro, and we are taking a look at certificates in Azure Key Vault. So that's one of the three: keys, secrets, and certificates. And so if you're wondering why we did all that X509 certificate stuff, it's specifically so that we are prepared to understand the purpose of certificates in Azure Key Vault. So Azure Key Vault allows you to import, generate, and manage X509 certificates. So the idea here is you can, generate one. You can self-sign one. You can use one with a certificate authority, but let's talk about some other things here. So Key Vault partners with certificate issue providers for TLS and SSL certificates. So we have DigiCert and Global Sign, those being two very large companies. You can generate self-signed or through a certificate authority. There's no need to manage the security of the private key. Key Vault takes care of it for you. It allows the certificate owner to create a policy that directs Key Vault to the managed lifecycle of a certificate. This allows certificate owners to provide contact info for notification about lifecycle events for expiration, renewal, or certificate. It supports automatic renewal with selected issuers. So Key Vault partners X509 certificate providers or certificate authorities. So there you go. All right, let's talk about the composition of a certificate within Azure Key Vault. And so we used this graphic earlier to describe the REST API interacting with just the certificate part of Azure Key Vault. But what it did show was the three components that are part of certificate that it will be stored in Azure Key Vault. So there we have Azure Key Vault, which allows the operations of keys, okay? Then we have Key Vault secrets, so allows the retrieval of the certificate value as a secret. Certificate metadata, so X509 certificate data. So if that's not clear, let's just get our pen tool out here. So we have the key, we have the secret, and then we have the metadata, okay? So those are the three components that are alongside the certificate. And so here we have an example of a certificate that I self-signed, I generated in there. And I just want to show you that you can download the certificate here in either CER format, CER, or PEM PFX format. And so you see where I'm like, is it ASCII? Is it binary? What's it going to be? Because, when I downloaded it, I didn't really get the exact result that I thought I would get. But remember that the PEM can be used as CER, so the format offering can be confused here. But what can help us understand is what we set the content type when we generate our certificate. So like CER will be ASCII format, I believe. But like when we're doing with PEM or PFX, the difference is going to be based on the content type that you choose there. So if you choose the content type to be PKCS #12, it will use that format. If you choose PEM, that means that it will download in the PEM format. Same thing with the CER. So just realize it is a bit confusing, and there's that additional option there. And Azure really should have not made these two buttons that confusing. It should have just been clear what they are, but that's just one of those things that Azure trips you up on, okay? All right, we're taking a look here at certificate policies. Certificate policies allow you to set and configure your certificate, such as the content type, the lifetime of the certification, the key type, the key size, and various other options, but it's calling it an issuance policy, so there's some inconsistency of naming by Azure between their documentation and their UI, which is no surprise. But we have a bunch of options, as we saw, so the type of the authority, whether it's self-signed and things like that, the subject, the validity period, the content type, whether it's enabled, the percentage lifetime, which I'm not sure what that is. We have advanced options where we can say the key type, the key size, things like that. Issuance policies only affect certificates that will be issued in the future. So it won't modify the existing certificate, but the ones that will be generated in the future, okay? Hey, this is Andrew Brown from Exam Pro, and in this fall long, we're going to be learning all about Azure Vault. So let's get to it. So what I want you to do is go in the top here and type in key vault. And here we'll have to go ahead and create ourselves a new vault. And so from there, we're going to create a new resource group. I'm going to call this resource group my example vault. And then we will make a vault key here. So I'll just say my vault example, which is kind of funny because this one's slightly different. So you've seen I've done this before. So I'm going to do my example vault as the name here. And for the region, US East is fine. For pricing, we'll keep it at standard. Soft delete is enabled. And then there's the option for purge protection. So we are going to enable purge protection. And this is going to play into other follow-alongs. We'll explain that as it goes. But purge protection does not allow you to purge things easily once it's enabled. So what we'll do is go ahead and review and create. And we'll go ahead and go review create. And we'll give it a moment here. And we'll just wait till it's done deploying, okay? All right, so after a short little wait, our vault is created. And so what I want you to do is go to the resource, and we're going to be using this vault a little bit in some of the follow-alongs, and in some cases, not so much, okay? Hey, this is Andrew Brown, and this fall long we're going to be doing some things with keys with an Azure Key Vault. So what I want you to do is make your way over to the keys blade on the left-hand side here. We're going to generate or /import a new key. We're going to choose the generate option. In terms of naming, we're going to call this my disk key. And we are going to choose RSA 2048. That seems totally fine to me. Everything else seems okay, so we'll go ahead and create that key. So we'll give it a moment to create, doesn't take too long. And then what we're going to do is go on the left-hand side to IAM access controls. And what we're going to want to do is add a new role assignment so we can go ahead and start using this key. So what I want you to do is go and look for Key Vault Administrator, which is here. And we'll go ahead and hit next. And then for our user, we will choose ourselves. So under user, I'm going to select the members. I'm looking for the account I'm using. There I am, Andrew Brown. Go ahead and select that there. And so that is all we need to assign it so that we can actually work with that key. So I think a good idea is to use a key to encrypt a disk. So what we'll do is make our way over to disk encryption sets, because before you can encrypt a disk, you need to have an encryption set. So we'll go ahead and create ourselves a new encryption set. We'll use the same resource group, so it's very easy cleanup afterwards. We'll call this my disk encrypt set here. And in terms of the encryption type, we're going to use double encryption because that's much better. You have two keys that encrypt it, so that's a lot better. We are going to choose our vault. So we have my example vault. There's only one option here. And in terms of the key, we'll select my disk key. In terms of the version, we'll select the current version. We'll go ahead and hit review create. And then we will go and create that. And we'll give it a moment to create that encryption set. Shouldn't take too long here. And after a short little wait, our resource should be deployed. It only took about a minute for me. And if we go here, it's going to have this message up here. It's very small, but it says to associate disk image snapshot this disk encryption set, you must grant permissions to Key Vault. So all we have to do is click that alert, and we'll grant permissions. And so now we are able to use that key, or like we're going to have the permissions issues is solved. So what we'll do is go to type and create a new disk. And so we can apply this key to that encryption. So we'll go ahead and create. We're going to choose the same resource group here. I'm going to call this my example vault, and my example disk, because that's a little bit more clear than that. And for the availability zone, doesn't matter. For the source type, it doesn't matter as well. In terms of the size, we want this to be cheap. We're not really using this for real, so we'll use standard HDD, and we'll say OK. In terms of encryption, this is where things get fun. We go to double encryption. We choose our key here. We'll go ahead, review, and create. And we'll just give it a moment for that to, we'll hit create, and we'll have to wait a little while here for the create that resource. So we'll just wait until that is created, okay? And after a very short while, the disk is ready. So we'll go to that resource. We'll go to the encryption tab to see that encryption is applied. So that's all it takes to use a key to encrypt a disk. So we are going to still use some of these accounts. There's no cleanup yet. I'll go back here, and I'll see you in the next one. Hey, this is Andrew Brown, and in this follow along, we're going to learn about backup and restore keys. So what I want you to do is go back into the resource group that we just recently created, and we're going to make our way over to keys. So we got to get into the vault first. Then we'll go over to keys, and the idea is that we have this key here. And so you can see that we have this current version, so you can add additional versions. But what's going to happen if we try to back this up? So when you back this up, you're going to get this file here. And if you open up this file, it's going to look like a bunch of gobbledygook. So I'm just going to try to open it here. I have it up off screen here. So I'm just trying to open it up within Visual Studio Code. So I'm just going to open up Visual Studio Code. Again, doing this off screen here. Just give me a moment. All right. And so this is the file that we encrypted. And you take a look here, and it doesn't look like anything, but the idea is that it is our backup of our key so that we can re-import that. And just taking a look at the key name, this is what it looks like. So this is my example vault, my disk key. Then there's this date, and that's key backup. So just recognize that's the format, and the date is very useful to indicate when you backed it up. So let's go ahead and delete this key, because the idea is we want to restore that backup. And so we have deleted that key there. And what we're going to do is we're going to attempt a restore. So I'm going to go ahead and go occurred while restoring the key. The key you're trying to restore already exists. Why would it throw that error? We've clearly deleted it. And the reason why is that we have purge protection on. We did that in the first part when we set up this actual vault here. I'm going to just see if we can find the settings wherever that purge protection is. I'm trying to remember where it is. Purge protection is enabled, so we can go here. And once you enable it, you cannot turn it off. It's going to retain it for a certain amount of days. And so all you can do is soft delete keys. So this key is not actually deleted yet. If you go to manage deleted keys, you can see the key is over here. And if you try to click on purge, it is disabled because we cannot remove the key because we have purge protection on. But we can recover the key, so we'll go ahead and recover. And so that will allow us to recover the key. And if we refresh here, it's going to take a little bit of time for that key to restore. So we'll just have to wait a little bit, and then it will show up. There's one other thing I wanted to show you was under policies, because, you know, if you go under, where's policies here, or access policies, if you look under our user here and we look at the key permissions, there is an option to purge. And we don't actually have that turned on right now, but if we were to save this and we were to still go to that purge option, it would still say the same thing. So even if you have purge permissions, it does not matter if purge protection is turned on. It still will not let you purge, but you would need a combination of those in order to be able to do things there. So to really show you how to do that recovery, I think what we should do, I'm just going to delete our old key here because we don't care about it. But we are going to, well, I guess we could try to import it into the other ones. I'm just going to undo that for a second. But we are going to go ahead and create ourselves another vault. So I'm going to go and type in vault at the top here. Now we're going to be a little bit more careful when we create this vault. So we'll go here and we will choose my example vault. I'm going to say my vault no protect. And the pricing tier will be standard. 1 day, we're going to leave it, 7 is the lowest, and we'll say disable purge protection because we don't want to have that enabled. And we'll see if we can import the key into another vault. I'm not sure if we can do that. Worst case, we'll make a new key, download the key, re-upload it. But I'm just curious what would happen if we tried to upload the same key as it's still in another vault. I'm not exactly sure. All right, so this deployment is successful. I'm going to go to this resource. I'm going to go ahead to go to create, and we're going to restore from backup. And we're going to take this key and see if we can actually import it here. So it looks like we can take a key and it can exist in multiple vaults. I'm going to go ahead and delete this key. And we're going to say, are you sure you want to delete this key? I'm going to say yes. And if we go to manage keys, and we refresh, it takes a little bit of time here. So we'll just wait a moment for this to persist. And after a short little wait, like about 2 minutes, I refresh and the key is here. So if I go here, you'll notice the purge option is still not available. We can obviously recover, but we don't have purge protection on. So if we go to access policies over here and we'll go ahead and scroll down and select purge and save our changes, we can then go back to keys. We'll give it a moment to save. We go back to keys, we'll refresh it, we'll manage our keys, and we'll go ahead and purge it, and that will permanently purge it there. So that's all it takes to do that. So there you go. Hey, this is Andrew Brown from Exam Pro, and this fall along we are going to learn about key rotation. So what I want you to do is make it back to the vault that we were just in, the no protect vault, and we'll go over to keys, and we'll have to create a new key. So I'm going to create a new key here called my new key. And it's going to be RSA 2048, and we're going to go ahead and create that key. So the idea of key rotation is that if you have, if you think your key's been compromised, or you have a policy like a company policy that you should rotate them for security purposes after a while, you can easily rotate out keys. So in order to rotate a key, it's as simple as going to your rotation policy here. And we can say rotate now, and that will immediately rotate the key. As you'll see, there is now the current version and the older version. So that was the key we had before. This is the new key. We can also set up rotation policy. So if we go to rotation policy here, we can set the expiry time to, let's put the lowest number in here, 1. So it says it has to be at least 28 days. And then we want to enable it. And then we want to automatically renew after a certain amount of time. So here, if I put 7, I'm trying to put the lowest number, so it goes 1, and I try 7, it says the value cannot be greater than 21 days because there's kind of a minimum and maximum about having a buffer. I don't exactly understand the math, but I know that if we change it to something like, I'm thinking here, expiry time 40 days, and there's a larger gap, this should be less of a problem. So it cannot be greater than that, 21. I knew the math here a moment ago. I could have swore it was 28 and 7. So just, well, I'm not sure that this is broken. Let's go ahead and save that. Try 40 up here and hit save. The value cannot be greater than 33 days. Okay, 33. Oh boy. So let me, all right, so the problem was I was in months, and we'll have to go to days here. So here, if we put 7, it works fine, but there is a bit of work to figure this out, and it will tell you, so you'll have to figure it out. We'll go ahead and save that. Oh yeah, it prompts again. So the time before expiry cannot be greater than 21 days, cannot be greater than. Okay, so we put the expiry to 40, we save. So there is a bit of work there. I don't exactly understand all the math there, but I guess it's a way so that you have less problems. But that's key rotation in a nutshell. So there you go. Hey, this is Andrew Brown from Exam Pro, and in this follow along, we are going to learn about secrets. So go back to your previous vault, the No Protect vault, and we'll go to secrets here, and we are going to go ahead and generate a new secret. And we're going to use this secret within an application. So we're going to have manual. We'll say my secret, and make sure you spell it right. So my secret. There we go. And for the value, I'm going to just say hello Mars. So it's a secret value. That's the whole point of secrets. For the content type, we're going to just say text plain so it knows that it's text. And everything else looks fine. So we'll go ahead and save that. And we will easily create ourselves a secret here. So the secret is now available. Now we just need to use it in some kind of application. So what I'm going to recommend is that we go use a Gitpod template. So we're going to say Gitpod template.net core CLI C#. C#. There we go. And from here, we'll click into it. And what we want to do is use this template. And we will have it private. It's totally fine. I'm going to go to Exam Pro here. And I'm going to call it, I don't know, Azure Vault Secrets.net. Oh, did I use that before? So we'll do new. If you don't have to do new, that's great. I'm going to go ahead and create this as a private repository from a template. So it's going to set us up with a base core .NET application. I think .NET 6.0. It's just going to make things a lot easier for us. So you can click the button down below. Actually, probably not because I'll go to the wrong repo. But what you'll want to do here is if you don't have the Chrome extension installed, all it's doing is it's just putting this in front of it to launch this Gitpod environment. So Gitpod has a free tier, so it's very useful to use, especially for .NET because we do have to do a bunch of setup for it. So I'm not really good at .NET, so this is the approach I like to take. And the idea is that we just close this and it cleans itself up. So it's really, really nice. So we'll just wait for the image to build and for the environment to run, and then we'll get to the next step, okay? All right, so after a couple of minutes, this environment's ready, and I'm just going to go ahead and hit the X there, go to terminal, and we're going to make sure this .NET app works. We're going to do .NET run, and this is just a basic Hello World application, so we can see that it prints out. So we're going to need a couple packages. So we're going to use .NET add package to add these here, so Azure Identity, and then we will do .NET add package Azure Security Key Vault Secrets. And the idea is we'll need to modify this file in order to load some stuff. So I can't remember if I wrote this myself or if I got it from an Azure documentation, but we'll write it out because it's not too much to write out. Using Azure Core, using Azure Identity, using Azure Security Key Vault Secrets. And then under the program, we want to modify our static void main. So we're going to need a new string, and this is going to be called secret name. So my secret, well, actually we have a bunch here, and I think this is where we probably should set environment variables. So key vault name, and I'm just going to, actually I don't know how to set environment variables in .NET. I don't want to look it up, so I'm just going to write it out and hard code it because it's not going to really matter if we do that. So I'm going to say my vault no protect. I think that's what we called it. My vault no protect, yeah. And for the key value URI, we're going to do this. So we'll say https:// my vault no protect .vault.azure.net. I think we need semicolons on the end here, otherwise it complains a bunch. Key vault name var secret client options equals new secret client options parentheses, and this I think is a function, so we'll open this up here like that. And we will try, we'll have to set this to retry. Don't worry if you don't know what's going on, because honestly, it doesn't really matter. it's just like, you just need to get some experience writing some code. And eventually it starts to sink in, because it really takes a lot of time to learn code. You just have to spend a lot of time doing it. So that we're just going through the motions without having to think about it too hard. So from second 16, and I'll explain it once we write it all up here. But yeah, it's very good practice to just write out code. Max retries is 5, and we'll say mode equals retry mode dot exponential. And I feel like we have to put semicolons in .NET, otherwise it complains. So that is that part. And then we'll need a client. So we'll say new secret client, parentheses, new URI key v URI, comma, new default Azure credential, parentheses, options, semicolon, key vault secret secret equals client get secret, parentheses, secret name, semicolon. And down here we'll do console dot write line, get secret, colon, get secret plus secret value. Value there. I didn't mean to spell vault. Capital V on the value. It's giving me some trouble here. Semicolon, and then the idea is we're going to want to enter the secret. Yeah, I'm pretty sure I took this from the Azure docs. I just don't remember where, because I know that this looks very familiar, and but I think I reorganized it so that it was a little bit more streamlined, because I think there was a little bit more going on with theirs. And so we'll say string secret value, lowercase secret value equals console read line, parentheses, semicolon, client set secret, secret name, secret value, and we can do console write set secret, semicolon on there. We'll do another console log here. This will be for the keys. I'll just give this out a couple spaces. And we'll do plus secret name. I guess spell this one right. And we'll do secret value. We'll do another console write. We're doing lots of these console writes here. Actually, it'll just be pretty much the same line up here, so we'll just go grab this one here. Client start delete secret name. Console write line start delete secret start delete secret plus key vault name. And then we'll go get it one more time. So let's take a look at this. I mean, hopefully we didn't introduce any mistakes by typing this all up by hand. But the idea, and these are supposed to have semicolons on the end, because I can see that little red mark there. So the idea is that we're importing core identity and key vault secrets identity so that we can get access to stuff. We're providing our secret, the name of our vault, the URL that it needs to hit to do that. Here it's going to get the secret client options. And so it's going to have a bit of retries here if it doesn't work out properly. Down below we have the secret client, so we're passing in the key value URI. And then we need our credentials here. We didn't type anything out for credentials, so I'm a little bit surprised by that, but maybe that's not an issue. And so what I'm going to do here is I'm just going to go ahead and commit all this. Actually, before we do that, we're going to create ourselves a git pod YAML file. So git pod init, and it says that one already exists, so I'm just going to say no there. But what we need to do here is install the CLI, the Azure CLI. So I'm going to make a new task here called Azure. We'll say init, and then here it'll be curl hyphen s capital L https:// aka at ms. Aka is like Azure's, Microsoft's shortener. So we'll say Azure CLI deb. Let's have install Azure CLI deb sudo bash. Okay, so that should install it. I'm just going to double check to make sure I typed this out correctly. And we will say allow and paste that in there. Yeah, it's working. So what we'll do is we'll commit our stuff here. Add that there. So commit code. And I guess we do want to run this line. So I'm going to go here and run it because the way it's going to get the credentials, it's going to grab it once we authenticate with the Azure CLI because it'll set something locally. And that's why we didn't have to pass in a key or anything. And maybe before we do that, let's just double check our permissions. So if we go to the IAM control here, we go to our role assignment, or actually access policies. We'll go to Andrew Brown, secrets, get lists. So we should be able to do it. We have all the permissions to do it. So now that that is done, we're going to go AZ login -- use device code. And hit enter. And so here we have this address here that will help us log in. So we'll go here to this address. We'll copy this code. We'll enter the code in. We'll say, whoops, that's not what I wanted to do. We'll paste that in again. And we will hit sign in here and we'll say continue. And that is all done there. So now what we can do is try to run the application. So we're going to type in .NET build to build this application, see if we get any errors. If we get errors, I'm not really surprised because we had done so much typing here. But we will go back to our code and take a look here. So on line 38, there's no semicolon. A very small mistake, so I don't mind that. If that's all the mistakes we wrote, that'll be great. Fix semicolon, missing semicolon. And we will commit and sync. .NET builds. And all projects are up to date, so that looks pretty good to me. We'll do run, and if it works, that'll be great. I don't know if we explained the whole program, but we'll just run this here. And it should run. Oh, you know what? It's prompted us probably. No, there we go. So we'll type in hello world. Hit enter. Great. So let's take a look at what this did. So the idea is that we have a client and we want to grab the secret. So that's the secret name we have up there, my secret. And if we console log it out, it gives us hello Mars because that's what we set. And then we are prompted to enter our own input. And we use this to set the secret. And then we immediately fetch and say, what is the key? What is the value? Now, if you notice, it says my secret here, hello world. But when we go get the secret, again, down below, let me just see here. So we have, and the reason why it's not printing out as expected is because we don't have, this is something I'm not a huge fan of in .NET, but you actually have to add the \n like that. Otherwise it gets a bit confusing here. As you can see, I'm a little bit confused about our output. So we have set secret, key value, my secret, hello world, that's new value. And then it goes down below and we print out the secret value again from the actual value object. So these are the ones that are just locally that we set, right? But this is the actual object. But the object is still saying hello Mars, but we updated it up here. And the reason why that happened is because it takes time for those changes to propagate. So if we were to call it again, it would have the right value, but you know, it has to replicate it. And so that takes a bit of time. So sometimes you have to wait for the stuff. So we go ahead and we delete it, and then we go start delete secret. So we say that we are deleting it, and then we go get the secret, but we've deleted the secret. So how can we see the secret if we delete it? And again, it just has to do with propagation. If we were to go into our vaults and to go to secrets, that secret should not be there anymore. So just consider that you have to do that. I think the original tutorial had like sleep commands. I don't know what the sleep command is in .NET, but it's something probably like sleep, .NET sleep, right? So they were running those in between that. That's like 2 seconds, 1,000 milliseconds. And so they're doing that to make sure the change is there. But I thought it was better to show you the fact that you have to wait a little while. But that's it there. So we are all done here. So we can go over to our resource group and we can delete this resource group and all the resources in it. All right, and we can close that off. So there you go. Hey, this is Andrew Brown from Exam Pro, and we are taking a look at Azure App Configuration. This allows you to centralize all your app settings in one location. It is ideal for multi-environment or multi-geography applications because it provides a dynamic way to change application settings without having to restart them. But in general, if you're building out any kind of application, it is actually really useful. It also integrates with Azure Key Vault, which stores application secrets, which we'll talk about soon enough. Azure App Configuration's main benefits are a fully managed service that can be set up in minutes. I would say seconds, to be honest. Flexible key representations and mappings, tagging with labels, point-in-time replay of settings, dedicated UI for feature flag management, which is, to me, the best part of Azure App Configuration, comparison of 2 sets of configurations on custom-defined dimensions, enhanced security through Azure Managed Identities, encryption of sensitive information at rest and in transit, native integration with popular frameworks. And when we say popular frameworks, we're talking about things like .NET Core, ASP.NET, .NET, Java Spring, other JavaScript, Node.js, Python, Azure Functions, .NET Core. So no Rails, no Laravel, so no Next.js. So I'm not sure what they're saying when they say popular frameworks quotations, but you can still integrate them because they do have language support. But there you go. All right, let's take a look at the tiers for Azure App Configuration. And we got 2 here. We got free and standard. So let's see what the difference is. So the first is resources per subscription, 1 for free, unlimited for standard. For storage per resource, 10 megabytes for free versus 1 gigabyte for standard. Revision history, 7 days versus 30 days. For request quotas, 1,000 versus 30,000 per hour. No SLA on the free tier. For security functionality, and this stuff is important, you get encryption with Microsoft Managed Keys, HMAC and Azure AD, so Active Directory authentication, role-based access control support, managed identity, service tags. So a lot of stuff in the free tier, but in the paid tier, you get customer managed keys, so CMKs, private link support. And then for the cost, it's free for the free tier, of course. And for standard, it's $120 per resource with 0.06 per 10,000 requests, with 200,000 requests are included in a daily charge. So you might like look at those requests and say, oh, that stacks up, but you get that 200,000 free daily. And for soft deletes is not supported in the free tier pricing. Okay, so soft delete meaning like I deleted something and I didn't actually want to delete it, so let's bring it back. It's like putting it in the trash can and then pulling it right back out. But there you go. All right, let's take a look at Configuration Explorer. This is where you're going to be looking at your data for the most part that you've inserted. And so the nice thing is that you go here, you can see the key and the value. Even though it's hidden, if you click values, it will show you them all, which for me doesn't feel super secure, but I guess that's how it works. Again, it just gives me a feeling of it not being secure, but it is secure. And the idea is that you'll be able to create a key value, but actually it's either key value, pair, or a key vault reference. And this is the way that you're able to reference secrets within your vault. So there's not really much to it. It's not super complicated. This view is fine. It does what it says it does, but there you go. All right, let's take a look at Feature Manager for Azure App Configuration. This is the meat and potatoes. This is the thing that you really want to be using Azure App Configuration 4, and it's for feature flags. So what is a feature flag? A feature flag provides an alternative to maintaining multiple feature branches in source code. A condition within the code enables or disables a feature during runtime, and this makes it easier to roll back or do A to B testing for new functionality. So Azure App Configuration Feature Manager allows you to add feature flags, which can be then accessed via code. So the idea is you say enable a feature flag, you name the flag whatever you want. So I call it flashcards, assuming I need a flashcard feature. You can label them, of course, and then you are providing code. Now, I didn't see much for things outside of .NET or C# and Java, so I'm hoping that their SDKs or there's some kind of library for Ruby, Python, Node.js, things like that, but it might just be only for C#, so .NET apps, and Java. Now, let's talk about an advanced feature of Feature Manager, which is feature filters. This allows filtering of features. So a feature filter consistently evaluates the state of a feature flag, and a feature flag supports 3 types of built-in filters: targeting, time window, and percentage, which is confusing because when you go and turn it on, it says targeting, time window, and custom. So the thing is that both targeting and percentage is within the targeting thing, and then custom is its own thing. So that is those little inconsistencies that Microsoft likes to present you in their documentation. So if we were looking at a time window, I think this is really cool, but you could say, okay, this feature starts on this date and it's between this time and I guess starts on and ends on that time. So it's like if you just want to run a feature for 10 days, you could do that. Then there's a percentage thing. So the idea is that you say, okay, I'm going to define 2 different groups. And for group A, they're going to get 50% of this feature. And group B, they'll get 50% of this feature. So it'll change the amount the feature is available per group, like how many in that group will get it. And then targeting would be like, you could say, I want it for these users. So when they say targeting, it literally just says user and you put a name in. It's just a text value. It's not like it's linked to an Azure Active Directory user or anything like that. And then they have custom filters, which can be created based on different factors such as device use, types, geography, location, etc. When I clicked on it, it wasn't very clear on how to do custom filters, but the idea is that you can go beyond these ones if you want to, have different values. So there you go. All right, let's take a look here at the Microsoft Graph API, which exposes REST APIs and SDKs to access data from the following Microsoft Cloud services. The first is M365 Core Services, where we have Bookings, Calendar, Delve, Excel, M365 eDiscovery, Microsoft Search, OneDrive, OneNote, Outlook Exchange, People, Planner, SharePoint, Teams, To-Do, Workspace Analytics. So basically a lot of services for enterprise mobility and security. We have Advanced Threat and Analytics, Threat Protection, which is ATP, Azure AD, Identity Manager, Intune. Then we have Dynamics 365 Business Central. For Windows 10 services, we have Activities, Devices, Notifications, Universal Print. And for supported SDKs, we have it for Android, iOS, Angular, ASP.NET, Go, JavaScript, Node.js, Java, PHP, PowerShell, Python. And they had Ruby, but I looked into it and it doesn't work anymore. And they say they're going to make a new one, but I'm still waiting for it. So I always get the short stick when it comes to Ruby. And the data is accessible via the unified endpoint at graph.microsoft.com. But how do we use this stuff? Let's take a look here. So for Node.js, we would install the Microsoft Graph client. And then here, as an example, we're sending an email. So the idea is, getting my pen tool out here, we create a client. We're defining some mail, and then we're calling our endpoint via the API. That's basically how you're always going to be doing it. Post that message, and that's how the Graph API works. So there you go. All right, let's take a look at Microsoft Graph Connectors. So Connectors offers a simple way to bring external data into Microsoft Graph and enhance M365 intelligence experiences. So you might want to build a custom connector to integrate with services that aren't available as connectors built by Microsoft using Microsoft Graph Connectors REST API. And you can use the Microsoft Graph Connector API to create and manage external data connections, define and register the schemas of the external data types, ingest external data items in Microsoft Graph, sync external groups, and Microsoft Search indexes all your M365 data to make it searchable for users with Microsoft Graph Connectors, so your organization can index third-party data so it appears in the Microsoft Search results. So you're like, okay, we have Microsoft Graph connectors. Where are they? And that's where I ended up on the connector gallery. So Microsoft has a gallery website containing 100 plus connectors. It's at microsoft.com/Microsoft search/connectors. And I was a bit confused at first, but now I understand what it is. But the idea is that they have a bunch of different connectors from a bunch of different third-party providers. So Microsoft has some, but there's a lot from a bunch of different providers. Some example connectors could be Amazon S3 by BA Insights, Azure Blob Storage by Accenture, Google Cloud SQL by BA Insights, IBM Connections by Raytheon, Google Drive by BA Insights, Azure DevOps by Microsoft. And connectors might not be free, and their instructions greatly vary based on the implementer. So this is not like a unified thing. It's you go there and it's like some other app that's used for it. So yeah, it's kind of weird because it just doesn't feel very standardized, but I guess it's just kind of a library of services that can connect things, kind of like Zapier, but as if there was all these specialized services by individual third-party cloud vendors. But there you go. Well, let's take a look here at Microsoft Graph Data Connect, which augments Microsoft Graph's transactional model with an intelligent way to access rich data at scale. So they're just meaning about getting data out of Microsoft and putting it into some kind of tool that can transform it, do AI on it, things like that. So Microsoft Graph Data Connect uses Azure Data Factory to copy M365 data to your application storage at configurable intervals. And the way this is going to work is you're going to have to go to the Microsoft Graph Data Connect under your M365 Admin Center, go to Settings, Org Settings, and Services, and from there you will turn it on. And the idea, once it's turned on, then you can go over to Azure Data Factory, and by adding it as a data set to your pipeline, you now have the ability to access your data. And if you know how Data Factory works, then you can do a bunch of stuff with it, store it in a blob storage, send it to Synapses, do whatever you want from there, okay? Hey, this is Andrew Brown from Exam Pro, and we are taking a look at Microsoft Graph. So this is a gateway service to programmatically access M365, Windows 10, Enterprise and Mobility, plus Security. And so here's the big graphic, but it's composed of three elements. So Microsoft Graph API, the Microsoft Graph connectors, and the Microsoft Data Connect. So here in the middle, we have Graph API. This is where you programmatically access various Microsoft services. You have connectors. These are ways of getting external data in to Microsoft Graph. And then you have Graph Data Connect. This is a way of storing data here. So hopefully that makes it pretty clear. I do find Microsoft Graph a little bit confusing because there's a lot going on here, but hopefully as we work through these slides here, it will make more sense, okay? Hey, this is Andrew Brown from Exam Pro, and we are taking a look at Azure Front Door, which is a traffic manager, traffic accelerator, global load balancer, and content distribution network CDN. And yes, it does all those things. And I think that what creates a lot of confusion for people when they first look at Azure Front Door. But the idea here is Azure Front Door is a modern application delivery network platform. So the idea is that it can do all these things. So provide a secure, scalable CDN, dynamic site acceleration, global HTTPS load balancing for your global web application. That's the definition that Azure has. But yeah, there are going to be services that have overlap with Azure Front Door, like Azure CDN and things like that. But just understand that this is a very robust thing and something that you're going to want to use quite often for your application. So Azure Front Door features caching like CDNs with rules expiring policies, resilience by distributing incoming traffic across multiple or different Azure regions, cookie-based session affinity for RESTful applications when traffic needs to be redirected back to the same backend. So that's for stateful applications. Health probes, which are very common at either the DNS level or the load balancing level, but since it is both here, it has it so to determine the healthiest and closest backend to the client request. It can have a WAF attached to it, so protecting your backends from malicious attacks and vulnerabilities. I believe that is using Azure's WAF policy, so you're just basically attaching a policy to that there. URL redirect, so redirecting traffic based on a variety of things, so protocols such as HTTP or HTTPS, the host name, the path, the query string. Not just that, there's a lot of stuff in there. URL rewriting, so with the powerful engine for rewriting incoming requests to a different backend request. And so in the simplest sense, this is what Azure looks like. You have front ends or domains where you're bringing stuff into Azure Front Door, and then you have your backends so that we can filter stuff there. There's actually a lot more components going on there. We will talk about them, or we'll have a diagram here to show you, but this is the basis of Azure Front Door. Well, let's take a look at the core components for Azure Front Door. And the reason I specifically made this graphic was because there was no real representation or example that I could find. And so I thought it was very important because when we start to talk about routing, the path looks completely different from this. It's similar, but it's different. So there is, I don't know why there's inconsistencies there. There is Azure Front Door Classic, but I was using the latest version. And so just understand that if you're confused, I'm confused too. But this is the visualization of what I think it works when you're actually using it within the GUI, okay? So the idea is you have a profile, and a profile, as far as I can understand, contains all the other Azure Front Door components. And then you have this idea of an endpoint, and this is the pathway from the front end to the back end. And within your endpoint, you need to have some kind of origin. So the origin is saying what to point at, so what to point at the back end. And even though it says origin here, it's really origin group. So you actually assign origin groups to an endpoint, and so it can route to multiple origins. Then you have a route, and so the route is where you can apply your rules and rule sets to determine more routing things. Then we have the ability to have a WAF policy before it reaches the backend. And so hopefully that makes it a little bit more clear. But one thing that is interesting when we talk about routing is that when they talk about the order of data coming in, they actually describe it as if the WAF policy is over here. But then when you look in the interface and GUI stuff, they put it on the right side. So whether it is here or there, I don't think really matters in practicality, but, I was trying to find that out. And the way data gets into Azure Front Door is that it's going to hit a edge location, and then that edge location is going to then trigger, I don't know why it says trigger, but the idea is to go to the front end. It should be more like match. But I have this kind of like expressway or highway to kind of emphasize that this is going to be very, very fast to get to your Azure resources. So hopefully that makes it pretty clear about the components there, but it'll be crystal clear when we do the follow along, okay? All right, let's take a look at what tiers we have for Azure Front Door, because the different tier is going to determine the feature set that is available to us. So Azure offers 2 tiers for Azure Front Door. The first is standard or delivery optimized. So the idea is you have content delivery optimized, offering both static and dynamic content acceleration. We get our global load balancing, our SSL offloading, domain and certificate management, enhanced traffic analytics, basic security and capabilities. And that sounds like a lot, but with premium, we get additional security optimized stuff. So we get everything we get in standard. But the idea here is we can have extensive security capabilities across our web application firewall. You can have bot protection, private link support, which I believe is for internal routing of traffic, keeping things within the Azure network, an integration with Microsoft Threat Intelligence and Security Analytics. Standard is really good for most use cases, but if you need that additional security, that's where premium is going to come into play, okay? All right, let's talk about how routing works in Azure Front Door, because there are a lot of components and it's important to understand the flow and also the different types of routing that are available to us. So routing is the path an HTTPS request from the user will take to reach a backend service configured in Azure Front Door. So at the start, you have that HTTP request from the user coming from their browser, most likely. And then the idea is it'll go over the internet and find the closest edge location. Edge location is just a point of presence, a data center or software or hardware that is on the edge of a network that allows you to enter the Azure network. And so from there, you are now going to be in the Azure network. And so you will be matched with a Azure front door profile. From there, it will then, if you have WAF rules, it will evaluate the web application firewall rules. And if everything's okay, it will then match you to an Azure front door route. And then from that route, it will then go through the engines rule to evaluate where to route things. If there is cached information, it will immediately return that information right away. But if there's not, it will just proceed to the next step, which is to send you to an origin group. An origin group is just a grouping of origins. And an origin is how you send a request to a backend. So, hopefully we'll see these components over and over again, so it's very clear how they work together. But let's talk about the 4 traffic routing methods that are available in Azure Front Door. So the first is based on latency. So requests are sent to the lowest latency backends acceptable with a sensitivity range. You have priority, so requests are sent based on a user-defined number. You have weighted, so these are requests that are distributed to backends according to the weight coefficient. And session affinity, so requests from the same end user get sent to the same backend. So these are for stateful backends, stateful applications. This kind of functionality for routing, like if you're using AWS, you'd see this functionality in Route 53, but in the case of Azure, we're seeing these within Front Door for this modern application delivery stack. Okay, so, hopefully that gives you an idea, but yeah, there you go. We are looking at Azure Front Door, and it's time to take a closer look at the origin component. So the origin is what Azure Front Door will point at to serve up to the end user, and origin is the endpoint that points to your backend. So here's the example of the form of the information you'll need to fill out. And the most important field here is the origin type, because that is what's going to say what are the supported backends or supported origin. So here we have Azure Blob Storage, Azure Storage for static website hosting, Cloud Service. Yes, there is a Azure service called Azure Cloud Service. I cannot remember what it does, but it is a service. We have Azure App Services. That's a place where we commonly deploy apps. Static web app, API management, application gateway, public IP address. So that would just be pointing to an IP, not necessarily a service. Azure Traffic Manager, Azure Spring Cloud. Spring Cloud is for Java applications, I believe. Azure Container Instances, so ACI, or custom, so you just provide a host name. Two other fields that are very important for origin is the priority and the weight. So priority determines who to send traffic to first, and this is going to be a number between 1 and 5. The lowest number is the higher priority. Backends can have the same priority number. For weights, this allows you to determine the split of traffic distribution between origins of the same priority. So if you had a priority 1 and somebody was 50-50, then they'd get 50-50 split between them. This number can be between 1 to 1,000. The default value is 50. And this is what it looks like when you add an origin to an origin group. So you can see the status is enabled. The priority is 1. The weight is 1,000. But there you go. So we just talked about origins for Azure Front Door. Let's talk about origin groups. So origin groups are a collection of origins, and an origin has to belong to origin group. So you can't just create an origin and let it float around in Azure. It's always going to be assigned to one. And when you create an Azure Front Door profile, by default, you will have an origin group called default origin group. And so here it is. And here you can see we have a default route for whatever we set up for this Azure Front Door. So a few other things you need to know, because there's more than just grouping. It's the fact that you can apply things to that group. And the two things you can apply are health probes to check the health of your origins, and load balancing settings to balance, determine the balancing of your origins. And in order for inbound traffic to reach an origin group, an endpoint needs to be associated to the origin group via a route. So there's a button in the interface here, which is associated endpoint to a route. It's that simple. But we will explore health probes and load balancing settings a little bit more. Just understand that they belong to the origin group, and those aren't just separate features that are floating around in the Azure Front Door UI or GUI there, okay? All right, let's take a look here at health checks, also known as health probes, and that's what it will be called when you look at it in the interface, but in the documentation, they'll call them health checks. And this is a feature found under origin groups, and then it will apply to your origin. So this allows you to ping a backend to determine if it has a healthy response. If there is a healthy response, which would be determined by status 200 OK, things will get routed to it. If it is not healthy or considered unhealthy, then simply traffic will not be routed, but instead routed to other healthy backends if there are other origins configured. So you might be asking, well, what is a HTTP response code? Just in case you don't know what it is, but the idea is that when a user sends an HTTP request, a HTTP response is returned. And so for HTTP responses, they will have a response code to communicate how backend servers interpreted the request. And a response code is a number that coordinates to what has happened. And there is a lot of them. So, but I'm just going to show you the most popular ones. So 200 for OK, 403 for forbidden, 404 for not found, 500 for internal server error. And I'm not kidding, there's like 100 of these. But these are the most common ones that you've probably seen before, but they all mean something, okay? All right, let's take a look at load balancing settings. This is another option that is available under the origin group. So this allows you to define what sample set is needed to be used to call the backend as healthy or unhealthy. So this is something you're going to be using alongside with health checks or health probes. So the idea is you have the sample size. So how many times or how many times do we need to consider? How many of the sample size have to be successful? And the latency between those, okay? So the latency sensitivity with the value of 0, we're just talking about this last value here, that if you set it to 0, it means that it will always send to the fastest available backend, else front door will round robin traffic between the fastest and the next fastest backends with the configured latency sensitivity. So there you go. So one thing you can do in Azure Front Door is assign custom domain names. And actually you can assign multiple custom domain names within Azure Front Door to show you the form. It's not too complicated, but the idea is that for DNS management, you can either use Azure Managed DNS or another provider. You are specifying the DNS zone name for the custom domain. You're going to add that custom domain. And you do have a couple options here for HTTP where you can have AFD, or bring your own certificate for enabling HTTPS. And you can apply either TLS 1.0 or 1.2. Of course, 1.2 is newer, so that's what you should be using. But there's really not much to say about that other than you can attach custom domains. Very straightforward, very simple, okay? All right, we're taking a look here at Endpoint Manager. So Endpoint Manager provides an overview of endpoints you've configured for your Azure Front Door, not to be confused with Microsoft Endpoint Manager, which is a security service specifically for managing external devices, so devices that register your company for organizations that are using outside of your office. So no relation to that product, just very similar naming. So this is an example of an endpoint that you will see in Azure Front Door. And the endpoint really means like the entry point. And so that's going to be the domain name. So if you do not have a custom domain, Azure provides you one at azurefd.net. It might vary based on capacity and things like that. But the idea is that it goes from domains to the origin group, to the routes, to security there. So, you know, hopefully that is pretty darn clear. Endpoint Manager lists how many instances of each element are created with an endpoint, and the associated status of each element will also be displayed. So there you go. Let's take a look at routes for Azure Front Door. So a route maps domains and matching route path patterns to a specific origin group. So here, the idea is that we can define what domain that we want to use. For this route, we can say what patterns we're matching on. So a wildcard is going to match on everything. Is it going to be treated as a redirect to HTTPS? Because if you have HTTP, you probably want to go there. And you're going to associate that with an origin group. And you can provide an origin path and define the forwarding protocol. Routes can also have caching and compression applied. So this is where you would start doing that. And routes from rule sets can be associated to routes to apply intelligent routing. So that's where you get that routing association. But yeah, there you go. Let's take a look at traffic acceleration for Azure Front Door, sometimes also known as global acceleration, depending on your cloud service provider. But the idea here is without any requirements to make any modifications to your application code, Azure Front Door can speed up global delivery of your application. So Azure achieves this traffic acceleration by directing traffic to the nearest edge location to on-ramp the Azure into the Azure network. So the idea is you have somebody that wants to connect. They're going to connect to that edge location, and an edge location is just basically a data center, a point of presence, hardware on the edge of a network. And then once you're in there, everything from here to the origin to the back end is going to be through the Azure network, and it's going to be like being on an expressway. So traffic that is following within the internal Azure network travels at accelerated speed while also taking the most direct path. Think of it as an expressway, and think of these edge locations as on-ramps. So there you go. Let's take a look here at rule sets for Azure Front Door. And this allows you to customize how HTTP requests get handled at the edge and provides more control behavior to your web application. So the idea is that you have a rule set, and within this, you're going to define rules. Just going to get my pen tool out here so you name it, and you can provide a condition and then an action. And we have a lot of options here for things you can do. So let's take a look at what those options are. For conditions, we have a lot of stuff: device type, HTTP version, cookies, arg strings, query strings, a bunch of things we can do with the requests, such as the body, file name, file extension, etc. So lots of conditions available to us. Then for operators, we have equals, contains, less than, greater than, and a whole host of other, even including regular expressions. For actions, this is where you really get very interesting things, but you can do cache expiration. So the idea is that the action is to expire the cache. You can have cache key query string. So the idea is you can cache every unique URL. So it's just a bit more complex caching. You can modify the request of the header or modify the response of the header. That might be useful for something to do. You can rewrite URLs. Redirect URLs. So the idea is that you can send it to different types of redirects, such as a temporary one or move like 301 or 307 or 308. You can rewrite URLs. You provide a source pattern and then a destination. You can override the origin group there. So a lot of stuff you can do within those rule sets. Hey, this is Andrew Brown, and this fall long we're going to be utilizing Azure Front Door. So before we do that, we're going to need ourselves a storage account to set up some static website storage. So what I want you to do is go to Storage Accounts. And there is a static web app hosting that we could use, but we're going to do it the old school way because it's always great to learn a few different ways to do things in Azure. And so there's probably another fall along where we use the static site thing there. So what we're going to do is create a new resource group. I'm going to call this one my Azure Front Door, and we'll say OK. And from here, we'll have to name it something. So we'll just say my Azure Front Door, or sorry, we'll do static storage 8888. If you can't get the 4 8s because I'm using it, then just give it a different number sequence because these are treated like fully qualified domains. Choose like a US region so that we're all doing the same thing. For performance, we're going to stick with standard. It doesn't matter if it's on geo-redundant. We're not doing anything fancy there. So what I want you to do is go ahead and hit review and create, and then give it a moment and hit create. And we're going to wait for that to finish deployment. And from there, we'll then have to enable static website. So it doesn't take too long to deploy. So we'll just give it a moment. And while that's going, we do need to create ourselves a index HTML file. So you're going to need some kind of editor. So I'm just opening up Visual Studio Code on my computer. Just give it a moment there. And I'm just creating a new file here. This is taking a moment to load. Okay, so and what we need to do is just create an index HTML file. These are really basic. You can find them anywhere online, but this one's going to say hello Mars, hello Mars. Very, very simple. So I'm going to go ahead and save this to my desktop. So save as, and show local maybe. There we go. That's a little bit more sane. And we'll just say index.html. And we will now go to the resource. And we're going to go to website static as a blade on the left-hand side. So we can do a static website stuff. We're going to say index.html. I think we have to set that for it to work. I cannot remember if that's the case. We have a primary endpoint. This is these matter for later, but we'll come back to that. And we're going to go over to our containers, and we're going to have to create a new container. So I'm just going to call that. Actually, we don't, because we're going to put it in web. So when we turned on static website hosting, it already gave us a blob or container, a container for us to add or upload our files there. So we'll go to upload here, and then I'm going to go ahead and select that index.html file and upload it in place. We need to change our access level for this container to, I think, just blob. So I'm just double checking here. Yeah, I think it's blob access. Can only be anonymous request. Container data is not available. So we'll say okay. I believe that is correct. Okay. Sometimes you can, like, we're clicked into it, but I think like in my instructions, I do it a little bit different. So I'm just going to double check to see what the settings are there, just so you can see it if you're following my instructions. So change access, private blob. Yeah. Okay. So that's fine. So blob access should be okay. And so now what we want to do is just test that our page is working. So if we go back to static website here on the left-hand side, we can grab this primary endpoint and we should be able to post it anywhere here. See, I have the old tutorial here. This is a moment ago, so that's why it's a bit confusing. But so Hello Mars is working, but this is on static storage. This isn't in front of or behind Azure Front Door, which is what we'll want to do next. So what I want you to do is just close a couple of these tabs out. And we're going to type in Azure Front Door, or Front Door should be enough, front. There we go. And we have a whole bunch of options. We'll just hit create. That's a front door we actually do use for the platform. We have Azure Front Door. We have quick create. I always go custom. I don't think I've ever done quick create. I just have more trust in custom. And from here, we will choose front door. And East US is fine. I'm just wondering where our storage account is. That's why we should always just kind of set them to be the same place. So we'll just go to storage account. I don't think it will matter, but I'm just going to double check. Storage account. And this one is in East US. So we're going to be okay. Just make sure they match, just so we have less problems. And I'm going to call this one my Azure Front Door. Now there are more functionalities in the premium, but standard is fine for us. We'll go next to secrets. This is if we want to add a certificate. Like you could bring your own certificate. But we're not too worried about that. We're going to have to add a new endpoint. So I'm going to just say my endpoint here. There's a lot of small steps in here, so this should be fun. Hopefully we don't configure anything wrong here. And then we need to add a route. We'll say my route. And it's going to use the default domain. That's totally fine. We don't have to do anything. It's going to just be on the / there. We do need to create an origin group. So we'll go here and create a new origin group. So my origin group. And then from there, we need to add an origin. Yes, it is very squirrely going through all this. My origin, the origin type is going to be storage static website. And from here, we need to choose the right one. We called it static storage. This is fine. This is all fine. We'll go ahead and hit add. And down below, we have some load balancing. We don't care about any of that. So you can see its status is enabled. All this should be okay. The protocol here for the health probe should be HTTP. Actually, let me double check because remember this is where I ran into some trouble. I believe, yeah, HTTP. I think it's HTTPS. Okay. I think I read somewhere that's like static storage doesn't use HTTP, but clearly it does because when we went to the link earlier, it was HTTPS. So I might have the screenshots wrong, but I've corrected them in the actual instructions on my site. We'll go ahead and save that. I think it's HTTPS. And then the protocol here, we'll just leave it matching. It's totally fine. Origin path is fine. We'll go ahead and add that there. And we'll go review create. We'll give it a moment and we'll create. All right, so after waiting about a few minutes, like 2 or 3 minutes, it looks like Azure Front Door set up. So we'll go to the resource, and I'm just hoping this works. Sometimes you have to play around with the settings, but if you see the endpoint host name, we'll go ahead and grab that there, paste it on in. We get a 404. So something's not working just right. So we'll have to go do some debugging, which I was hoping we didn't have to do. So we go to the Front Door Manager. This is the same setup we have here before. There are like different ways to get to it. But we'll have to just kind of go through and debug it. So we do have my route, my origin group. So we can click into our origin group. And then from here, we'll expand it. And we have our route. So there's something that is not correct. And that's what we have to figure out. So I'm just going to double check my instructions because this was a bit tricky to figure out. And it really came down to like these protocols here. So let me keep checking. And I mean, I think the probe is working correctly. So if we go in the origin, if this wasn't working correctly, then it wouldn't show green. So go back up a step here. You know what? Maybe we should just wait a little bit because sometimes it takes time to propagate. And I don't 100% trust that it's not working because I feel like we configured it exactly right. So I'll open up a new tab here. It says 404 still. My origin group. That's fine. We'll go here. Yeah, so what I'm going to do is go back to our storage account. I just want to double check what that string was for the static website. I'm pretty sure it was HTTPS. It is HTTPS. So there's no reason that should not work. This is what I was trying to spare you, the debugging of this. And it's very common. It's not just Azure. Anything that has a CDN, sometimes it's difficult to figure that stuff out. But we'll go ahead and edit that route. And we'll just carefully look at what we have here. So patterns and match, that is fine. It's the correct endpoint. Both protocols are accepted. That's totally fine. Redirect HTTPS, that's totally fine. Match, that doesn't matter. So it should just work. The only thing we didn't do was enable caching, which I think wouldn't hurt to do. Because it is a CDN, we don't take advantage of it if we don't turn it on. So we'll do that and say ignore that query string. I mean, that's not going to fix this problem if the routing's messed up. Again, I'm just hoping that maybe it just has to do with propagation. We'll go back to the overview here. And we will open this again. Whoops. Grab this. Let's just make sure it's doing HTTPS. We're working to restore all services as possible right now. What do you mean our services aren't available right now? Let's go look at Azure status page here. And we'll take a look at front door. Azure front door. It's saying that it's fine. US East. There's no green beside it. Good. So we go down here. I guess it's a non-regional service. So if it's green, it's green. So you know what? I'm going to play around with this for a little. Oh, 404 web. So this is better, right? It's just saying it can't find the content. Well, I mean, I guess that makes sense because that was there. So we'll just clear that out. Oh, now it's loading. So I think what the issue is there was no issue. It's just propagating to all the servers and it took some time. So I think that's what really threw me for a loop when I was originally doing it. So just give it some patience and it will work eventually. So we are all done here. So we can go ahead and clean this up. And I'm just looking for the resource group here. We'll go ahead and delete it. And there you go. That's Azure Front Door. And I'll see you in the next one, okay? Let's take a look here at Application Insights, and this is an application performance management service. So it's an APM, and it's a subservice of Azure Monitor. Let's talk about what APMs are. So these are monitoring and they do monitoring and management of performance and availability for software apps. APM strives to detect, diagnose complex application performance problems to maintain an expected level of performance. So why use Application Insights? Well, it automatically detects performance anomalies and includes powerful analytics tools to help you diagnose issues and to understand what users do with your app, designed to help you continuously improve performance and usability. Works for apps for .NET, Node.js, Java, Python, hosted on on-premise, hybrid, or any public cloud. And I know that it works for other ones that are not part of the supported languages. So there's one for Ruby. But the thing is like Azure's only providing official support for a bunch of languages, but you might still have libraries out there for them. And it integrates with your DevOps processes and can monitor, analyze telemetry from mobile apps by integrating with Visual Studio App Center. And if you're running an app, you definitely want to have an APM installed. If you ever use Datadog or Skylight or New Relic, that's what APMs are, or what those providers offer. But let's take a closer look here. And this is kind of an example of an application. And what you're going to see is that we have a front end, a back end, and workers, just to kind of represent how you can instrument your applications. And when we say instrument, it just means install like this piece of code that runs on it to send data back to Application Insights. And the idea is that when you instrument it, you're just installing the instrument package SDK, or in some cases, you can just turn it on where it's supported. So you don't necessarily have to install an app. You might just press a button and it will install it within Azure services. And there's many ways that you can view your telemetry data. So the idea is that the agents send that information to Application Insights, and then you're going to be able to leverage that in alerts, Power BI, Visual Studio, REST API, continuous exports. A lot of services can ingest Application Insights. So apps can be instrumented from anywhere. So if you're running on AWS, you can install it on your servers there. When you set up Application Insights monitoring for your web apps, you create an Application Insight resource in Microsoft Azure. So it's a physical resource. And you open this resource in the Azure portal in order to see and analyze telemetry collected from your app. And the resource is identified by the instrumentation key, also known as the I key. And I just got a big old list here just to tell you all the things you can do with it. So what does Application Insight monitor? Well, request rates, response time, failure rates, dependency rates, response times, failure rates, exceptions, page views, load performance, AJAX calls, user and sessions count, performance counters, host diagnostics, diagnostic trace logs, custom events metrics. So there you go. That's a big old list. And on the right-hand side is where can I see my telemetry? And we saw a little list, but let's go through the big list. And that's smart detection and manual alerts, application map, profiler, user usage analysis, diagnostic search for instance data, metrics explorer for aggregated data, dashboards, live metric streams, analytics, Visual Studio, snapshot debugger, Power BI, REST API, continuous export. And there you go. So you can see that it can collect, and you can use it in a lot of places. Definitely install if you're using or you're running a web application. Oh, let us quickly talk about OpenTelemetry. So OpenTelemetry, also known as OTel, is a collection of open source tools, APIs, SDKs, instrument, generate, collect, and export telemetry data. So OTel standardizes the way telemetry data, metrics, logs, traces are generated and collected. It uses a thing called wire protocol, which refers to a way of getting data from point to point. And Application Insight supports OTel as an alternative to Azure Analytics SDK for instrumentation. So OpenTelemetry is very popular in the cloud native space and Kubernetes, and it probably is the future of metrics. So it's a standard, and so we're seeing adoption, not just by Azure, but by AWS and Google Cloud. So it is worth knowing about this alternative method. Will it show up in the exam? Maybe not, but I definitely want you to know what OpenTelemetry is, okay? Let's talk about instrumentation for Application Insights, because if you don't do this, you're not going to be getting data to your Application Insights. So you instrument your application by adding the Azure Application Insights SDK and implementing traces. It supports a variety of languages, .NET, Java, Python, Node.js, JavaScript. No Ruby. I'd really like Ruby support, please. So you do npm install Application Insights save. That's the JavaScript example. Here I'm requiring it. We're doing some setup And then from there, what you can see with the client is we are tracking an event, we're tracking an exception, we're tracking a metric, we're tracking a trace, we're tracking a dependency, we're tracking a request. So there's a variety of things we can do, but there is auto instrumentation. We'll talk about that soon. But this is the idea generally, is that this is what instrumentation looks like, okay? So wouldn't it be nice if we didn't have to instrument our app, that it would just work? And that's where auto instrumentation comes in. It allows you to enable application monitoring and application insights without changing your code. And it's supported for a variety of different things. So support's going to vary, and you'll have to just come back and check if this is even true still. I did just get this table, but Azure moves really fast. But let's take a look at what I'm looking at right now. So across the top, we can see .NET, .NET Core, Java, Node.js, Python, and there is a term called ONBD, which means on by default. So another thing is going to vary based on service. So for Azure App Services, pretty good support across the board, except for Python, which is surprising. For Linux, not for .NET because it just doesn't let you have it, and not for Python. For Azure Functions, we only have it in public preview for Java. For Azure Spring Cloud, it's only for Java again, which makes sense because Spring is a Java thing. So these will never get supported here. They should really say NA. Azure Kubernetes Service, so only for .NET Core and maybe through the agent. Virtual machine Windows, on-premise virtual machine Windows, they're the same here. And then for standalone agent, we have generally available for Java. So not a lot of support, but there is some. So, if you're in the .NET world or in the Java world, it looks like you're going to be in really good shape. But there you go. Hey, this is Andrew Brown, and in this follow along, what we're going to do is learn about using Application Insights. So Application Insights allows us to get visible data about how our application is running, like distributed tracing. And so we're going to have to deploy some kind of workload and then apply Application Insights to it. So what we'll do is go ahead and go to App Services and deploy a new service. So let's just type in the top here, App Services, and we'll go here. We'll go ahead and create ourselves a new app service. And I'm going to make a new resource group here so it's easy for us to clean up later. So My App Insights. And then from there, we'll need a web name. So we'll say My App Insights 8888. If you cannot get this name, just change the values to something that works for you, because these are fully qualified domains. It's like registering domain names. So make sure it works for you. We're going to publish code here today. For the stack, we're going to choose Node just to make our lives super easy. I'm choosing 16 LTS. If there's a newer version, should work fine. Node does not change that much in terms of versions, but it depends how far in the future you are. In terms of region, Canada, US, Central US is fine. It always chooses by random. I'm in Canada, but I'm going to stay in Central US because I know that the things I'm going to be using will be available there. In terms of the SKU and size, which greatly affects the cost, we'll click into here because we really do not want to pay much at all. So we'll give it a moment to load. It'll take a few seconds. Well, it usually doesn't, but for right now, it certainly does. So we'll give it a moment to load. I'm going to make my way over to Dev Test, and we're going to choose the cheapest option here, which is going to be F1. So you can see there's not a whole lot. It's just memory storage. We don't get custom domain. We don't get manual scaling. We don't need any of that stuff. We need it nice and simple. So we'll go ahead and choose free F1. That sounds good to me. I like the word free. We'll go to our next step, which is deployment. In fact, I don't think anything has to be changed under deployment, but we'll click it here. Not sure why Azure's a bit slower today, but that's just how it's going. So we'll give it a moment to think, and we will wait. Wow, it is really, really slow here right now. Okay, so for deployment, you could hook up GitHub Actions and things like that. I don't think we need to do any of that, so I'm going to make my way over to networking. And we do want to inject, not networking, monitoring, because we don't need networking monitoring, but we want to enable Application Insights. This is going to set up some stuff for us. So it's going to set us an Application Insights, namespace, a thing. It'll set up something for us, so we don't have to worry about that. So we'll go ahead and hit review, create, and hit review. And so now we just need to wait for that to deploy. So I'll see you back here when that is done, okay? After a very short wait, maybe like a minute or two, that has been completed. So we'll go ahead and go to that resource. And I just want to show you over here in the configuration tab, the environment variables that are going to get passed to our application. So if you go here, these are the environment variables that get passed along. And notice we have one called application insights connection string, instrumentation key. And the reason this is important is because we don't have to, in our environment, set it. So like, since we're using app services and we enabled application insights, it's already going to set those values. And the great thing about the SDK is it's going to pick up those values, so we don't have to explicitly set them. At least I don't think so. If we do set them, we'll use the environment variables. I haven't decided as of yet. For application insights, it set us up I don't know what they call them, workspace, namespace. I don't really care what the name is called, but the idea is that we have an environment set up in order to gather information. So what we're going to do is just go back here and notice down below it says node is in progress, agent is enabled. So just indicate that that is working as expected. That's a good message to see. Not that we'd ever see any other message there. And so now that we know that everything is deployed, or at least our environment is ready, let's go ahead and create a new application. So what I'm going to do is make my way over to GitHub here, and we are going to create ourselves a new repository. Now, I don't know if I have an old one sticking around here, so hopefully I don't. Well, we'll see here. I'm going to say my app insights would be something I would name it. And so I already have one there. So what I'm going to do is I'm just going to make a new tab here. Okay, I'm just going to go to anyone here. This is my marketing website. I'm going to go my app insights. I'm just going to rename the old one so it's out of the way. So you can follow along exactly the same way as me here. I'm just going to go settings. We will go down here. We'll just say old. All right, and we'll rename that. And I'll close that out. And so what we'll do is go back here, and this is fine now. I know that it says it's not, but I know it is. We're going to add a README file. We're going to go down to git ignore and add node. I might have done this after the fact, so I might have added the steps out of order here, but that should improve that there. I'm just going to do -old. I'm going to take that out there. There we go. And we'll go ahead and create this repository. So I want you to get Gitpod installed. So Gitpod is a really great service for having a cloud developer environment. It has a generous free tier, so there's no reason not to sign up. And really, this is the future of cloud development. So make sure to go get a Gitpod account. But you really don't have to, because when you launch this environment, it either launches it temporarily, or you can connect your account and then persist that data. But anyway, if you install the Gitpod Chrome extension, you'll get this button. But you don't need to install the Chrome extension. All you have to do is you just need to put this in front of your address. So this is the current address we're at. Like, this is the current repository. Whoops. This is the current repository link, and all this button is doing, copy link address, is just putting this part in front here, okay? So this is going to open up a Gitpod environment. This launches extremely fast, and we're going to create a new Node.js application and deploy it to app services. So we'll give it a moment here. Doesn't take too long. Here we go, and what we'll do is we're going to use the npx express generator to generate a new express application, express.js generator. So we'll type that in there. We'll say yes, and it's going to create us a skeleton app. Just say yes. Just say yes all the way down. We'll get a bunch of stuff in here, and then we'll do our npm install. You can do npm install or npmi if you want to make it nice and short. We'll give it a moment there. Okay, and then we'll make sure this works. We'll type in npm start. This is going to prompt us to open our browser, so we'll say open browser. So Express.js, that application's working up at this link up here. So this is our application, but it's not instrumented to send any data, so that's what we need to do. So next thing we're going to do is just kill this, Control-C. Control-C on my keyboard. And we'll type in npm install. I'm typing application insights --save. And what that's going to do is install that dependency for application insights. So if I go over to my package.json here, you can see that it is a dependency that is installed. So now we need to configure that. So what we'll do is go over to our app.js file. And so we got to insert this somewhere here. So what I'm going to do is I'm going to go all the way to the top. That's probably a good place to put it. And we'll say let. I like how it says all var. Var is really old. App insights equals require, double quotations or single. It doesn't matter. It's not going to hurt either way. Application insights. And that will define our variable here. The next thing is we need to set it up. So we'll say app insights dot setup. And then we need our connection string. So that's where we're going to put this thing here. Our connection string. And then we need a bunch of other things. So I'm not going to type these all out because there's a lot of them. So we'll just say application insights instrumentation, Node.js. And I'm sure the documentation is going to help us out there. So go here. I'm just scrolling for the usual configuration. Here it is. That's all I've been typing here this entire time. That's probably where I got it originally. So we'll go ahead and we'll just paste that on in there. Allow. We'll take out the first line. That way there's no spelling mistakes. And so we have auto dependency correlation, auto collect requests, a bunch of interesting stuff here. It's going to do distributed tracing. We don't need the semicolon. We'll just take it off there for fun, and I'll save that. And so now the next thing we need is the connection string in order to make sure this application works, which is going to go here. So we'll make our way back over to this tab, and the connection string is actually in the configuration that we were earlier here in this blade. So we'll give it a moment to load. There we go. And so we want the connection string. So we'll click that. I think before that you could use the instrumentation key, but now connection string is what is preferred. I want to copy the value. Okay, I just clicked into it to make it a bit easier for me. And what I'm going to do, this is really dirty, but I'm going to just paste it in here. And we're going to just do it in a few different steps just to make sure that this is working correctly before we switch this over to environment variables. And one other thing that we need to do if we want to actually get any data is we'll have to turn send live metrics to true. Now, if you are doing instrumentation, you might not want live metrics. I don't know if it costs more, but for our development purposes, it's not a big deal to turn this to true. So that is now enabled, and you know, our .get_ignore should have a bunch of stuff in it, like node modules, so we're not committing that stuff. And I'm going to commit this. Now, it does have the connection string in here. I'm not too worried about it because we are going to delete it out later on. So we'll just say save my changes. But I am pointing out to you that we are committing this string here, which is bad practice, right? Because if somebody got that, then they could mess with this. But again, we're going to tear all this stuff down, so it's not that big of a deal. And so we should be okay. So now that this is installed, what we're going to do is do an npm start. That's going to start up our application. And then we're going to go open in the browser again. So here's our application. Now, if we go back to application insights, or not application insights, but into our app service, our actual application, on the left-hand side, there's going to be application insights. And from here, what we can do is click the view application insights to go to the workspace, the namespace, whatever they want to call it. And this is the way we're going to be able to see some information. So live metrics on the left-hand side will show us data in real time. So now it says it's connected to your app. So we'll go back here, refresh, so the app connects, and we should get some data. There we go. So these are the requests we're making right here. So I hit enter, 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 enter. We go back here. Here's those requests coming in. It's giving a 304 for the CSS. So yeah, mostly, yeah, there's our stuff. So we know that it's working because we can see information there. And so that's pretty darn straightforward. Now let's go back to our application, set this up properly, because we really shouldn't be setting our string like this. This is pretty dirty. So what I'm going to do is just delete this out here. And I'm just going to type in process.env, and then we're going to say, we'll match the name of what it's supposed to be called in our application. So I'll click back to make it back to our actual application. We'll go to configuration. And from here, I'm going to just go ahead and grab that string name. I just clicked into it. I just don't want to type it wrong. And we'll go ahead and paste that in there. And so this is what we are going to set. I just did Control-C to kill there, but this is what we're going to set as our environment variable. So I'm doing GP. GP stands for get pod. It's a way of setting environment variables. And we'll do double quotations. Always do double quotations, especially with connection strings when setting environment variables. So part of the string does not get cut off, because it will cut off at the first // and then you'll just end up with like that. And that's not enough, right? So I've copied that. I'm going to go back here, paste it in. We'll hit enter. And so that's setting the key. Now, if I do grep, or sorry, env, so show, like this prints all the environment variables. So env pipe is just a vertical line, grep and I type in connection, any part of the string, notice that it's not set yet. So just because we said gpenv does not mean it's set. What you have to do is restart the environment, but we can temporarily set it, export. This is how you'd set it in Bash. You type export and you'd give it the name here like this. And you do equals double quotations. And this will make the environment work, but the only problem is that if we restart this workspace, we'll lose that on the next time we restart it. So this will definitely work, but let's just do it. Let's just restart the environment anyway. So we have process env up here, but we have to import that as well. So I'm going to say let process equals require process. Process is just a way of getting access to the process. Process being the application that's running to access the environment variables that are set, which are getting passed along to the application by app services. So that is good there. And so I think we are in good shape. The only other thing is I want to generate a gitpod file. So I'm going to just do gp for gitpod, and we'll just set some things up. This is just going to save us some time when we relaunch our environment. So I'm just doing pipes here. On the end here, that allows us to do multi-line, even though we're only doing a single line. We could probably omit the pipe if we wanted to, but I'm just putting it in anyway. And so we'll just indent there. Coloring usually tells us something's wrong. And this starts up on port 3000. I want it in the browser. I don't want to do preview. That means opens in a little window here. That's kind of gross. And so this looks good. I think I accidentally removed a line here because it's supposed to say tasks up here. And so now we have our gitpod YAML file. So we'll go ahead and add all these files here. So instrument. I think that's everything we need to do there. So we'll just go ahead and commit that. We'll sync our changes. And I'll do a git push just to double check. Double check that this stuff was synced and committed. So if you go back to our actual GitHub, if you go context, it just brings us back to the GitHub repository. That gitpod YAML file set, so we know that our changes have been committed. Highlighting looks fine. I know this is green. This kind of looks blue. So hopefully that works. But anyway, what we're going to do is go ahead and open this again. Sorry. We'll close this tab and we'll reopen up in gitpod. And so this will launch a new workspace. If you still have the old tab open, it might ask you to physically press the button called new workspace, but generally it opens a new workspace. So it's setting up a new container completely for us. So give it a moment. It doesn't take too long. And what we'll do here is wait for the terminal to open. Okay, notice it ran the server, it did npm install, did everything for us. I'm just going to open a new terminal here on the right-hand side in Bash. Whoops. Oh, I did not mean to split it, but that's okay. I don't know how to unsplit it, so just drag it around. Yeah, it doesn't matter. Yours will look a little bit different than mine. And so all I want to do is do env grep con. So I want to see that connection was set. We'll do 2 ends. So there it is, application insights connection string. So I'll just go ahead and close this one. I'm getting a bit confused here with that open. And our app should still work. If we go on the left-hand side here to Remote Explorer, it didn't give us the prompt here. Notice that this little red thing says, all right, you're blocking this pop-up. Continue blocking? No, always allow us to pop up on this. And I'll just click the a little world button to see that it's running. So it's still working. We're going to go double check to make our instrumentations working with our new connection string that's being passed through as an environment variable. So on the left-hand side, go back to Application Insights. And we'll give it a moment here to load. We'll go back to viewing the data. On the left-hand side, we're going to go to Live Metrics. It says it needs to reconnect. We'll hit refresh here. If it connects, then it must be working. So refresh, 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 go back. The data is coming in. So therefore, it is working. So we are in good shape here. So our application is configured correctly, but it's not actually deployed because we're passing we're passing our own environment variables in. So let's actually get it deployed to app services. So what we'll do is click back to get back to our app services, which is here. Nope. Oh yeah, it says app service. That's good. And on the left-hand side, we want to deploy it. So we'll go to the deployment center. And what we'll do is we'll choose the code and we'll go to GitHub. And from here, we need to authenticate. So Omen King's my personal account. That's just the way I get to it. And so I need to select an organization. It's Exam Pro. I need to select a repository. This is going to be my app insights. That's the new one. We'll choose the main branch. It knows what the runtime is, and we'll go ahead and save that. So as soon as we do that, it should automatically start deploying. It's using GitHub Actions as the build provider. So if we go back to the repository here, we go to Actions, we can see we have one queued up. And so this should run on its own. We don't need to do anything. So all we're doing is waiting for this to deploy. And once it's done, then our application should be deployed to our URL. And then we'll check to see if it works. And if it works, then we are in good shape and we're done the basics of application insights. So I'll be back here in a little bit, okay? All right, so it's done. I was waiting here for quite a while, but I think it was done in a few minutes. You just have to hit the refresh here. So, you know, don't be afraid to go up here and hit enter and see if it's deployed. But now that it says it's deployed, I mean, this URL is on Gitpod, so that's no good for us. What we'll do is go back to our application all the way top to the overview tab, or blade, I should say. We'll go to browse and see if it's deployed. So we're hoping we see Express.js. The first load might be a bit slow, so we'll give it a moment to think. It sure is thinking hard. And we'll just close it again and reopen it. We are using the free tier, so I'm not sure if it's like spinning up the instance. That's probably what it's doing. It's probably spinning up whatever the underlying environment is to get it running. So it is running here. Now the next question is it tracking? So we'll go over to Application Insights, and we'll go back to viewing our insight data, and we will go all the way down to Alive Metrics. It says it's not connected. We'll hit refresh. Give it a moment here, see if it finds any data. We'll hit enter. There we go. So we're having a couple of requests in there. So we have Application Insights working and it's deployed. So we're in pretty good shape here. We're going to keep this environment around because we need it for a few follow-alongs here. But if you want, you can tear this down, but you'd have to do all this setup again. But you can see it doesn't take too darn long. But there you go. Hey, this is Andrew Brown, and we're going to take a look at sampling with Application Insights. So this is a very short follow along, but very useful for you to know. So we have this application, and what I want you to do is open it up in Gitpod. You should know by now how to open things up in Gitpod. And we'll give it a moment here, and we're going to configure this to do sampling. So sampling is when you don't send every single trace to Application Insights or every single request information. And the reason why you'd want to do this is basically to save money, because if you had all your data going there, it's just too much information, right? So and that cost will stack up a lot faster. So you know, applications might send only 50% of requests, only 22% of requests. It's up to you to decide how much data you need to have something that's accurate, but you definitely don't need all of it. So I'm taking the start off the end of here, and I'm just going to have App Insights start here. So it is set here. And then what I'll do is do App Insights. I think we should do before. I think in my code, in the code example, I have it in the wrong order, but I don't think it even matters. But we'll do client config. It might matter actually. Sampling percentage equals 50. So we're saying only sample 50% of the time. I'm just going to double check, make sure that's spelled right. App Insights, default client config, sampling percentage equals 50%. And so now if we set that there, and I'm not going to test it in the app. I'm just going to test it in Gitpod here. But what we'll do is we'll go back to our application, into the Application Insights tab, view that. We'll go to the live metrics. And if we go back over here and stop our application, start it back up, okay, and we go here, this should connect. And so what I want to do, I don't know, I'd say it's not supported, it's definitely supported. We'll hit 1, 2, 3, 4, and we'll go back. And notice that I hit 4, but I only have 2 requests. So that's why we're only getting 50% of it, because it's going to cut out 50% of the requests. And I think, yeah, it should always do that. So that's all I wanted to show you, because that is something that is a very basic configuration that you should know for Application Insights. But we're going to keep the environment around because we have a few more things to do. But yeah, there you go. Hey, this is Andrew Brown, and we are going to look at usage analysis with application insights. So usage analysis allows you to get more rich information about the usage of your application. So I'm just here in application insights for our app that we've been using. If you go on the left-hand side and scroll on down, you'll see this usage tab. So we have users, sessions, all this interesting stuff. It allows us to instantly create cohorts, which are extremely useful for visualizing information. If you've never seen a cohort before, like user cohort, I don't think it matters what cohort we look at, but I just want to show you an example of one. So this is a cohort, and the idea is that if you have an application, you want to be able to see whether users are coming back every single day, right? So you go, okay, this person was here on day one, and the same person came back, or 23% of the people came back on the second day, 18% of the people came back on the third day, and it gives you kind of a map of cohorts, like information about your user behavior. So very, very important, very useful for your application, and Application Insights allows you to collect that information. Now, what we're going to be doing here is we're going to be instrumenting the client side, because we instrumented the server side when we installed it into our backend server code, but we never did in the front end. So that's the first thing we're going to need to do. So I just need the code snippet to do that. So what I'm going to do, I'm going to go back to our repository because we're going to need that open here. So we'll go back to my app insights. I'm going to open that up in Gitpod. And while that's going, I'm going to type in application insights instrumentation, Node.js. And we should easily be able to find the code for this here. I want it client side though. I'm just looking for it. So, because there's all sorts of pages here, so it could be a bit, well, let's say usage. How about application insights, usage analysis. Here's a page. Yeah, and that's the code we want. So it's on this page here, usage analysis with application insights. So I'm going to copy that code, and that's going to go into, I'm going to make a new workspace here. That's going to go into the front end of our website. So somewhere in the index HTML. Or if they're called Jade files, then it'll go into there. So it is a, Jade file. It's just opening the browser for us here. So what I'll do is go index Jade. Jade is just the syntax language that is used by this configuration of Express.js. I'm going to go ahead and paste this block in here. And we actually have to format this a bit because Jade's not going to like this. So what we'll do is type in script here at the top. This is just how this language works for JavaScript tags. We'll do parentheses, type equals, single quotations, text, JavaScript. Okay? And then from here, what we'll do is just go ahead and select this. Okay. And I'm just looking where we should put it. So they probably want it in the head, so we'll put it right here. And yeah, so that's fine. That looks good to me. We're also going to need to create some kind of cohort. So what we'll do, I'm going to just commit this. Add client side tracking. Okay, and so we'll stop our app, start it back up. Okay. And back over here, I just kind of want to show you where you can set up. We're not going to be able to see a real cohort because we'd need multiple days to collect information. But let's just kind of play around as if we do have the data. So over here on the left-hand side, we'll go to sessions. And it should tell us how many sessions we have. Now, there was no information showing it before, but now we're seeing 2. Okay. So I'm not sure if it's counting both the server side and the client side, but we are getting data, so that's good. And if we went up here to create a cohort, we have a template gallery, so we could choose a variety of different ones. So we might want to try a blank sessions cohort. Sessions are people that are connected to the application. Users are identified users. And so, you know, we can add parameters to filter things down, but we don't have to do anything. We can also like run the query to see what information we get back. But we'll go ahead and just save this cohort. So we'll just say my cohort, whatever you want to name it. Doesn't matter because we're not going to see anything interesting anyway. And so this is our cohort, but you can see there's nothing interesting. So if we want to see something, that kind of looks like a cohort. What we can do is make our way over to workbooks, I think. Yeah, over here. I'm not sure if this is just the same thing, but in a different place. But if you go down below here, they have usage like active users and things like that. I'm looking for retention, so maybe cohort analysis. And so down below, you can kind of start seeing a table here, right, of what that looks like. So I find the workbooks a lot more useful than the usage tabs, but yeah, I just want you to know about this usage analysis because it's super useful that Logins or Application Insights has that functionality. So, you know, hopefully that is good enough there, but that is all we're doing here. So I'm just going to go home, close these tabs, and I'll see you in the next one, okay? Hey, this is Andrew Brown, and in this follow along, we are going to do a bit more with Application Insights by putting in custom events, which is very useful for tracking. So what I want you to do is open up Application Insights for our project that we've been working with. We'll also have to go back to our GitHub repository and open that up in Gitpod, as you should know how to open Gitpod by now. And we'll give it a moment there to load, and we'll enter in some code. So we do have server-side and client-side tracking. We did the client-side tracking in the usage section there. But if we expand this here, we're going to want to put something in the index.jade file. And so here, what we will do is add a new script tag. So that's going to be script. This is Jade language. I don't care if you learn it, but you just got to follow along for this purpose. Coding is not the lesson here. But we have text JavaScript, so that allows us to do some JavaScript there. And I don't know why it's saying tab when I type. That is not very useful for me, but I'm just going to do space and type in app insights, track, event. We'll autocomplete that there. We'll do parentheses, curlies, name, double quotations, client count. And so every time this page loads, it's going to do track event with this name, and that's going to count up. It's called client count. That's how we know it's on the client side. So that's the index page there. And so now we need to do server side. So there's a few things we have to do here. We've got to go to app.js. And in here, we need to set a variable that's going to get passed along. So we'll go down below here and do app.set parentheses app insights. And this is specific to Express.js. So again, I don't care if you remember how this works, but it's just a way that we can pass a variable that we're going to access in our routes. So we go app insights default client. And I'm going to make sure we have that. Yeah, it's up here. So we're passing this in here. So that's good. We'll go over to our routes. And in our routes in our index page, we need to add app insights. So we'll do app insights. And we're going to grab it from that app variable we just set. So we do app request app get app insights. And then we'll track it. It looks exactly the same as the other one. We are using JavaScript on the front end and the back end. So it makes things a little bit easier. And this one's going to be called name, double quotations, single quotations, doesn't matter, server count. Okay, so now we have it, server side, client side. I'm going to go up here, just commit my code, client and server side tracking. We'll commit that. And what we will do is we'll do an npm start to restart up the application. Now that we have both sides of it, we do have a problem here on line 8 of index.jade file. So we'll go here, take a look at what it's complaining about. Does not like something. So I'm just taking a look at my code off screen here. It's line 8. It's this line it doesn't like. So why not? I mean, I don't see a problem. So what happens? I'm just going to copy my. Oh, you know what? It's indentation. See where it says block content? It's supposed to be this level here. That's probably the problem. So we'll stop it. We'll start it. We'll give it a second. It's still crying. It's a big old crybaby here, but that's okay. We'll work through it. Now I hit tab. It's actually tabbing properly because I wanted to do tab before. I don't know why it was doing that. Still doesn't like it. So I do have the code off screen here, so I'm just going to copy paste it. I mean, you'll have, if you're on my platform, you'll have it. So you just say allow Oh, there's a period on the end. Of course. Could barely tell that was there. Okay, so we'll save that. Again, I don't care if you learn J templating. It's not a skill you have to remember. So that is there. I'm just going to keep hitting enter because I want to observe this custom event data. So we go back over here into App Insights, and we should be able to see this somewhere. This would be under where? This would be under somewhere. I'm trying to find it. It would be under which blade? Huh, I didn't write it out in my instructions, so we'll have to click around here to find it. I think, well, it's event data, so it's probably under events. Yeah, that's where it is. Now I'm remembering. And what we can do is filter this down and say any custom event here. And if we scroll on down, we'll go view more insights. I don't know why they have a little button there to get that information, but if you scroll on down, we have server count. So server count is definitely working. We don't know why we don't see client count. So what we'll do is go back here and we'll right click and see if there's any errors. There is an error. App Insights is not defined. And so it should be defined in the head because we have this script from before, right? You know what? We didn't put the instrumentation key in. So that's not good because in the last follow along we were supposed to do it. But it didn't really matter because we didn't have any data to look at, so that's why we didn't notice. So we'll go back to our overview and we'll grab the instrumentation key here, go back to our code, and we will go up to app.js. And this is client side, so it's a bit harder to pass it in as environment variables. We're not even going to try to do that because it's the instrumentation key. It doesn't matter. And we're going to go back to the layout here, and down below we'll just replace that. Okay, we'll start it, hit refresh, right click to see if it's working now. Just give it a refresh here. It's still saying App Insights is not defined, which is not true, but there is an error here. We'll click into it. It's not showing me the line, which would be nice. Okay, so we'll go back here, and there's something wrong here. It doesn't like something. You know what? It's probably missing the period. There we go. Can't believe we never noticed that before. So fixes, I'm very confident that is the fix. So we'll go back here, inspect, refresh. Already lost that. Let's do inspect again. No errors here. That's good. We'll hit refresh, 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 refresh. We'll go back to application insights. And we will go back to events. If we can find it, there it is. And I'm going to go down to any custom event, scroll on down, more insights. And it might just need some time to propagate because we're not getting any errors now, so it must be working. If it didn't track, it would give us an error. Client count. So it is showing up, so it is counting now. So that's how we do custom event tracking. So there you go. And for the most part, I mean, the only thing we didn't look at was application map. Take a quick look here. This would show you like connections in between stuff. So here we have like the web to the client. If we set up other things like a database and stuff like that, we would have something more interesting. That's more of an advanced thing. And, you know, maybe I'll do that in another follow along, but this one is done. So let's go ahead and clean this all up. You can delete this repository. It's no big deal. If you're worried about the connection string, you can delete that whole, the repository. But since we are tearing everything down, it's not going to matter. And I know we replaced it as an environment variable, but remember, it's in the Git history. So someone went back, if got access to your GitHub repository, and went back in time, they could find it. But what I'll do is I'll go to resource groups. We'll look for our app insights here, and we will hit delete resource group. We'll say my app insights, go ahead and delete, and there's our cleanup. So there you go. That was application insights. So Azure Monitor is quite a beefy service. There's a lot going on in it. And so it's a comprehensive solution for collecting, analyzing, acting on telemetry data from your cloud and on-premise environments. So here's an example of one of the things it can do, which is provide you a visual dashboard, but it can create smart alerts, automate actions, log monitoring, and a lot of different things. And many Azure services by default are already sending their data to Azure Monitor, so you can use it right away. Now, I just want to introduce you to the concept of the pillars of observability. This isn't a thing specific to Azure, but it's something that in DevOps that you need to understand, and it's just going to help you contextualize the offerings of Azure Monitor and other cloud service providers. So what is observability? That is the ability to measure and understand how internal systems work in order to answer questions regarding performance, tolerance, security, and faults with a system and application. And in order to obtain observability, you need three things. You need metrics, logs, and traces, and you have to use them together. Using them in isolate does not gain you observability. So let's go define those three things. The first thing is metrics, and that is a number that is measured over a period of time. If we measure the CPU usage and aggregated it over a period of time, then we would have the average CPU metric. Then you have logs. These are text files where each line contains event data about what happened at a certain time. And then you have traces, and this is a history of requests that travels through multiple apps and services, so we can pinpoint performance or failures. And I like to make the joke that it looks kind of like the Triforce of observability once you've constructed it there at the end. Let's look at the anatomy of Azure Monitor, which is a little bit complex, but I'm sure we can work our way through it. So the first thing is that we need sources of data. So this is what data can be sent into Azure. So you probably want application data, operating system data, data from Azure resources at your subscription level, your tenant level, which is going to be associated with Active Directory, and custom sources. And once you get those into Azure Monitor, you have to store them somewhere. And you're going to put them in logs and monitors. And these are just data stores that are within Azure Monitor that you're going to be able to work with. And once you have that data in there, you're going to be able to leverage different services to do different things. And so we will call these functions. So you can perform insights, visualizations, analysis, response, and integration. So we'd look at insights. We're getting insights into our virtual machines, our containers, our applications. For visualization, you might be making dashboards. You could be using Power BI or creating workbooks. For analysis, you might be using the log analysis or the metric analysis tools. For responses, you might want to create alerts or start auto-scaling. And for integrations, you might want to use logic apps or export APIs to connect things up. So there you go. So now let's take a closer look at all the different sources because this is going to really help us understand the utility at each level. And I think that makes everything very crystal clear. So remember that list of sources where we went to application to custom sources? We're going to start at the top of that list and look at application code, which is all about performance and functionality of your application and code. So that's like collecting traces, application logs, and user telemetry. And so here is the visual representation. And so on the left-hand side, we have our sources. In the middle, we have our storage. And on the right-hand side, we have our services that we're going to be doing things with that data. So looking on the left, in your application, you'll probably want to go ahead and install the instrumentation package. This is going to allow us to collect data into Application Insights. And Application Insights is an application for getting rich data about our applications. Then you have availability tests. This tests the responsiveness of your application from different locations on the public internet. And that's really useful if you're saying, like, if you have your application, you're running it in the east of Canada and the west of the US, and you want to make sure that the response times are the same or lower, that's going to help you get there. For your metrics, this is going to be describing performance and operations and custom metrics of your application. For your logs, you're going to be storing operational data about your application, such as page views, application requests, exceptions, and traces. And then the things you're going to be putting in storage is you're going to send the application data to your Azure Storage for archiving, or what you'll do is you'll store your availability tests if you need to go and analyze them further. Or you could create a debug snapshot of your data so that you can then go debug that at a later point. Okay? So let's take a look at how we're going to monitor our operating systems. And this is for the guest operating system, not the host operating system. So when you're dealing with virtualization, the VM has its own OS, but the actual underlying hardware has its own OS, and that's the host one. And that's not what we're looking at. You don't need to monitor that one. That's up to Azure to do, or your cloud provider. We're looking at the guest one, the one we actually can control. So the operating system is going to need a couple of tools installed, or agents. So we'll want to install the log analytics agent so we can use that with log analytics. We'll probably want to install the dependency agent. That allows us to monitor processes on the machine. So those are the programs that are running. So like, let's say MySQL, Redis, maybe you have a Ruby on Rails app, whatever. And so that's that. And I just want you to know that these agents can be installed anywhere. So it can be installed on Azure, on-premise, or even on other cloud providers like AWS. If you want performance counters, you're going to have to install the diagnostic extension, which is, I think, a good thing to do. And just to make note, the log analytics agent is going to store that data into logs. Then you can use that in log analytics later. If you want to have store the health state information, then you're going to be using the Azure Diagnostic Extension, and then they're going to put that in Azure Storage. And if you want to use Azure Event Hub, so Event Hub is a way of connecting your app to other destinations. You're going to stream it, but you're going to need the Diagnostic Extension for that. All right. Let's take a look at Azure Resources and how we're going to monitor those. So you're going to have resource logs, and these provide insights to internal operations for Azure Resources. And these logs are automatically created for you, but you will have to set diagnostic settings to specify a destination for them to be collected for each resource. For metrics, you're going to get those automatically. You don't have to do any additional work to configure them, and you're going to be able to analyze those in Metrics Explorer. For your log data, you're going to use log analytics to look for trends and other analyses. You can also copy your platform metrics to logs for analysis. And your resource logs are going to be archived in Azure Storage for long-term backup. If you want to use or send or trigger or send your data to other destinations, you can use Event Hubs. That's generally what Event Hubs is for. So there you go. Taking a very quick look at how we monitor our Azure subscription. This is going to be for the service health of different resources that you're using, like are they okay, are they running, and things about Azure Active Directory. So that's about it. Going to take a look at our Azure tenant and how we would monitor that. And if you remember our Azure AD section, that's where we define tenant, because tenant is highly coupled to Active Directory. And so this is going to be for tenant-wide services such as Active Directory, so reporting that contains history of sign-in activity, audit trails of changes made within a particular tenant, things like that. So there you go. So last on our list here is custom sources. And basically, if none of the other previous categories fit where you want to collect data, this is where you can just collect data using the Azure Monitor API. And so basically, you're using a REST client, and then it's going to store it in analytics at Log Analytics or Azure Monitor. So it's just really custom data or custom storage. So there's two fundamental types of data that we care about when working with Azure Monitor, and that is logs and metrics. And so Azure has two services to deal with that. One is called Azure Monitor Logs. And so this service collects and organizes log performance data for monitored resources. Data logs are consolidated from different sources into workspaces, which we'll talk about. Platform logs from Azure services is something it'll collect. It'll collect also log performance data from VM agents. The usage and performance data from applications also can be consolidated, and these workspaces can be analyzed together using a query language, which we definitely cover in this course. And you work with these log queries and the results interactively using a subservice called Log Analytics, which is something we'll definitely be covering. Then there's Azure Monitor Metrics. So this is for the metric side. So collect numeric data for monitor resources into time series database. Metrics are numerical values collected at regular intervals and describe some aspects of a system at a particular time. Lightweight and capable of supporting near real-time scenarios, useful for alerting and fast detection of issues. And you can analyze them interactively using Metrics Explorer, and we cover that as well. So really, these two services are like the data stores or the databases for the respected types of data. And then each of them have the subservices, which is for exploring and some other additional services. But let's get into that more in detail now. So when you use log analytics, you're going to probably want a workspace, and this is a unique environment for Azure Monitor log data. Each workspace has its own data repository and configuration, and data sources and solutions, and are configured to store their data in a particular workspace. So it's really interesting because if you go over to Azure Monitor, you can use log analytics without creating a workspace, but I believe that if you want to isolate a lot of your data and install maybe collect data outside of Azure services for other things, you're going to need a workspace, and it's going to also have a lot more robust options. So that's something you're going to end up doing is creating workspaces, and it's a good habit to do. But there's not a lot to talk about there. But let's move on to the query language, which is really the meat of log analytics. I want to quickly touch on log analytics. And so this is a tool used to edit and run queries within Azure Monitor logs. And so the idea is it kind of looks like something you would use to connect to a database, because it really is structured like a database with tables and columns and things like that. And it has this its own query language called KQL. And the idea is that you input your queries, and it's going to output results for you. And that's something we're going to look at in greater detail, is that KQL language, so that we know how to use that panel. But let's go talk about workspaces. Let's take a closer look at Kusto and its query language. So Azure Monitor Logs is based off of the Azure Data Explorer, and along came with it is the Kusto query language, also known as KQL. And this is the way we're going to filter and sort and do things with our logs. So Kusto is based on a relational database management system, and it supports entities such as database, tables, and columns. It also has this thing called clusters. And KQL actually has a lot of utility in Azure, because it's not just in Monitor logs and Data Explorer. You can use it in log analytics, log alert rules, workbooks, dashboards, logic apps, PowerShell, Azure Monitor log APIs. So it's definitely something you're going to be using across the board in Azure. And so they have some basic operators. They have lots of operators that you can use. So you can do calculated columns, searching and filtering on rows, group by aggregates, join functions. And we're going to be looking at a lot of the operators in more detail after this slide here. But anyway, the queries execute in the context of a Kusto database that is attached to a Kusto cluster. And we will talk about clusters, database, tables, and columns up next. Let's take a look at what makes up something for Kusto. And so we have a bunch of entities here: clusters, database, tables, columns, and functions. And so I have this nice visual to help us kind of see how they all work together. So at the top we have clusters, and these are entities that hold multiple databases. You can also have multiple clusters, but it's just not being shown there in that graphic. Then you have the databases themselves. These are named entities that hold tables and store functions. You have tables. These are named entities that hold data, and a table has an ordered set of columns and 0 or more rows of data, each row holding one data value for each of the columns of the table. Then there are the columns themselves, and these are named identities that have a scalar data type. Columns are referenced in the query relative to the tabular data stream, and that is the context of the specific operator referencing them. Then we have stored functions, and these are named entities that allow reuse of Kusto queries or query parts. And then you got these external tables, and these are tables that live outside of your cluster. I think that you're referencing them from storage accounts, and they're in blob storage. So I think they could be like CSV files and stuff like that. But these external tables are used for exporting data from Kusto to external storage, so storage accounts, as for querying external data without ingesting it actually into Kusto. So hopefully that gives you an idea, the lay of the land there. Let's take a look at the type of data types that we can use in Kusto, but let's just define what scalar and data types are. So scalars are quantities that are fully described by a magnitude or numerical value alone. So the idea is that it just means like a single value. Then you have data types, and a data type defines how a piece of data is interpreted. So an integer number could be a data type. If you've ever used programming languages like data types and stuff like that, or an SQL database, you should be familiar with those. So in Kusto, data types are used for various things. So they can be for columns or function parameters that expect specific data types that they want them to be. And so let's just go through the quick list of data types because there are quite a few here, and I've summarized them quickly. So the first is Boolean, and this represents a true or false value. Then you got date times or date, and this represents a date. And these are stored in UTC time zones. You got decimals. These are numbers that like are 12.88 or something with a decimal in them. You have integers, which is like a whole number. Then you have longs, which are also integers, but with a greater range. You have your GUIDs or your UIDs, and these are unique values. So it's like a random hash there that you have. And the idea is just so that you have unique values, but they're not like 1, 2, 3, 4, 5, so people can't guess the size of your tables. Then you have reals. These are double precision floating point numbers. So these are really, really big numbers, something you probably use if you're doing things with finance or numbers. Then you have strings, and these are Unicode strings, and they're limited by default to 1 megabyte. And the way you do them is you have them wrapped in quotations. We have that hello world. You have time spans. These are interesting. These are little time intervals represented. So like 2D would equal 2 days, 30M would equal 30 minutes, 1 tick would equal 100 nanoseconds, and they have a variety of those. Then you have dynamic, and this is a special type that can do a bunch of things. So it can accept primitive scalar data types. So the idea is it's kind of like a data type that can accept any value, or it can accept an array of any value, or it can accept a property bag, which, if you're from the JavaScript world, looks like a JSON object. So you have a key and value, and it can even be nested. And then last, which is a data type, but you're not setting these as your columns, which is the null. And that's a special value that represents a missing value. And any of these data types can be a null value. So like you look at Boolean, it can be true, false, or null. And date time can be a date time or date or null. And that goes for all of them. Let's talk about Kusto control commands. This is really part of the KQL language, but it's a way of kind of working with the databases and tables and stuff like that. If you ever use Postgres and if you've done like / du, or you have these commands that didn't really have to do with necessarily querying, but like managing the databases and tables and stuff, that's what control commands are. So I'll give you an example. So here we have a control command to create a Kusto table. So they always start with a period. So period create table logs, and then it makes 2 columns in that. When you're using the query like log analytics and stuff like that, you can just type period and then start typing it, and it'll show you all the list of control commands. It was really hard to find the documentation a full list. Otherwise, I would have picked some out for you. But generally, you can just kind of explore that way. Or the most common ones you're going to come across is all going to be in the documentation, even though there's a very long list of control commands. A very common one you're going to be using a lot is show. So for example, we can do .show tables and then count the number of tables there are. And so I just want to show you that if you type .show, it'll show you what it can take as a second parameter. And there's a huge list there. So just an idea like how you can work with control commands. Take a look here at Kusto functions, and these are reusable queries or query parts. And Kusto supports several kinds of functions, the first being stored functions, which are user-defined functions. And these are stored and managed as one kind of database schema entity. Then just to define user-defined functions one step further, they come in 2 categories. We have scalar functions. So these have input scalar data types and output scalar data types, and then tabular functions. So these take input tabular data and they output tabular data. Tabular data is just when you're working with multiple rows in a table. Then you have query-defined functions, which are also user-defined functions and that are defined and used within the scope of a single query. So very similar to stored functions, but it's all based on scope, okay? Then the last on our list here is built-in functions, which are hard-coded, and these are defined by Kusto and cannot be modified users, and they just give you a lot of utility. Let's take a look at some of these built-in functions, starting with special functions. So select Kusto entities. So you might want to say, I want to select a cluster, and then I want to select a database, and then that table. Then you have aggregate functions, which perform calculations on a set of values and return a single value. So maybe you want to do a count. So you see where it says count and parentheses. Then you have Windows functions, and these operate on multiple rows and records in a row. And so one really popular one is row number. And so this could count the number of rows. Maybe you have to figure out the row numbers in relation to your query. And so that's something you could do there. Let's take a look at some scalar operators, and there's quite a few here. And these are for working with scalar data types to do comparisons. And there's a bunch of different categories, so let's just quickly go through them here. The first one is byte-wise operators. That's where you're working with zeros and ones and flipping them around to do different things. So you got the binary end, the not, the or, the shift left, the shift right, the XOR. And these make a lot of sense if you know how to work with binary math. If you don't worry about them, but I just want you to know if you do, they're there for you to use. Next are logical operators. So this is what you're going to be more familiar with, like equality, so equals, unequal, and or. So this is pretty darn simple. Then you have date time and time span arithmetic. And so we have add or subtract date times. So you can do that. You can add, subtract, divide, or multiple time spans. So add 1 day plus 2 day makes 3 days. Then you have numerical operators. These work on ints, longs, and reals. So you can add, subtract, multiply, and divide. You can do module, where it's determining whether it's a whole number or not, so, or divisible by a whole number. So like, let's say you have 17 and you put it through there. You say module 17 by modulus 2. If it's not divisible by 2, like perfectly resolves into 0, it will return either 0 or 1. Then you have less, greater, equal, not equal, less or equal than, greater or equal. So you got the idea there. Equals to one of the elements, so that's in. So you do the in. It's very familiar if you're used to using SQL. Then you have the opposite, where you put an exclamation in front of it. Actually, there's a lot of extra operators that just have the same thing with an exclamation to mean the opposite, especially with string operators. So here's a bunch of string operators, and they almost all have exclamations, a variant with exclamation in front of them. Then you have your between operators. This matches the input that is inside an inclusive range. So you can say between 1 and 10, or between these date times. So there you go. Let's take a look at custo-tabular operators, and I really want you to pay attention to this one because this is where all the power of KQL happens. So these perform comparisons against a bunch of rows. That's why it's called tabular operators. And there's a lot of them, and we're going to look at the most common ones because it would take me forever to go through all of them, and you're not going to remember them all. So let's just look at the ones we actually care about working with. So the first is count. This returns the count of rows in the table. Then you have take. This returns up to a specified number of rows of data. You have sort. This will take the rows of the input into the order by one or more columns. So you see by damage property descending. So it's just sort. Then you have project, returns a specific set of columns, and where filter a table to subset of rows that satisfy a predicate. Before we move on to the next slide, I just want to point out, like if you've worked with SQL, these are very familiar, right? Like take is like limit, sort is like order by, project is like select, okay? Moving on to the next one here, we have top, returns the first n records sorted by specified columns. This is kind of like a shorthand. I think it like makes take and sort and just abbreviates it to one line. You have extend, creates a new column by computing a value. So notice that it says duration equals end time minus start time, and then we're using duration somewhere else. Then you have summarize, aggregate groups of rows. That's kind of like group by in regular SQL. And then render, so renders results as a graphical output. And to me, that's a really cool one. Moving on to metrics, we're going to be looking at Metrics Explorer. So Metrics Explorer is a subservice of Azure Monitor that allows you to plot charts, visualize correlating trends, and investigate spikes and dips in metric values. So the idea is you can create a really cool graph like that, and you can make a variety of different ones based on how you want to chart it out. But let's talk about how would we define one of these metric visualizations in Metric Explorer. So you got this cool bar, and the idea is you got to fill it all the way to the end, and then that will visualize it for us. The first is the scope. So you're going to open this up, and it's going to allow you to select resources. So it'll show you like subscription and stuff like that, and resource groups, but always makes you select a resource at the end. And some services you can select multiple resources, and some you can only select a single instance. So with storage account there, it's only going to be a single one there. So I had one called Daystorm Institute I made. And then there you're going to choose a namespace. So this is a specific group of metric data within a resource. So notice like it makes sense for a storage account that it would show account, blob, file, queue, table. It's going to vary based on your service. Then you actually have the metric you care about. So we have availability, egress, ingress, etc., and a bunch of other things. You're going to choose one of those. And then you're going to choose how you want to aggregate it. So average, min, max, etc. And again, this is going to be totally different based on what resources you choose, but that's generally how it works. Let's take a look here at Azure Alerts, and this helps us be notified when there are issues found within the infrastructure or application, and this allows us to identify and address issues before the users of your system notice them. And so they come in three flavors. We've got metric alerts, log alerts, and activity log alerts. And when an alert is triggered, you can be notified or have it take action. So here is kind of the anatomy of an alert, and we have the alert rule. This defines who we should monitor, like the service, and like the definition of when it is triggered, which is going to be the next part here. So a resource such as a virtual machine designated as the target resource will emit signals. So it's going to be emitting a data payload, and it could be of the following types. It could be a metric, a log, activity log, application insights. You can kind of see how that ties to the types of alerts. Then you have the criteria or logical tests. This gets evaluated and determines, are we in a triggered state? It could be like percentage CPU greater than 70%. Then you have your action group, which contains actions, and those actions will be performed when it is triggered. And actions could be things like run an automation run book, use Azure Functions, ITSM, Logic App, webhooks, or secure webhook. On the other side there, we have this box over here, and this is all about the state of your alert. And so we have monitor condition alert state. So monitor's condition is set by the system, and alert state is set by the user. But the idea that is there is so you can define where it is, because you might want to have a history of saying, okay, I've resolved this issue, so I'm marking this as closed, and that'd be like an alert state there. And so there you go. This is probably not going to be on your exam, but it's super cool to show, and it's only one slide away. So let's talk about it, which are Azure dashboards. These are virtual workspaces to quickly launch tasks for day-to-day operations and monitor resources and build custom dashboards based on projects, tasks, or user roles. So the idea is you can go in here and you have like this little tile editor, and you can drag stuff over. So you can see I can put like a video in and a link to the help support and put a clock and some metrics I care about and some markdown. So it's a really good way of building out these customized dashboards based on a user role to really help you focus on what you have to deal with within your infrastructure on Azure. Let's take a look at Azure Workbooks, just because this is in the scope of Azure Monitors, so we should cover it. So Workbooks provide a flexible canvas for data analysis and the creation of rich visual reports within the Azure portal. They allow you to tap into multiple data sources from Azure and combine them into a unified interactive experience. And so the key word here is story. It tells a story about the performance and availability about your applications and services. So this thing kind of looks like a dashboard, but it isn't. And it's highly customizable, but it's not very clear in here. But really what it is, it's like the form of a document. And the idea is that imagine that you have a document and then you can embed analytics in it that are real-time analytics, so that you can visualize and kind of investigate and discuss performance and availability and stuff like that. You can kind of think of it like if you have ever worked with Jupyter Notebooks, but it's really for performance and monitoring. It's kind of like that, okay? And these things are highly customizable and really useful. And if you ever use Datadog, Datadog has its own thing. I think they call them notebooks as well. Instead of workbooks, they're called notebooks, and it's the same thing. But it's a really great tool for really understanding your performance. Hey, this is Andrew Brown from Exam Pro, and we were looking at Azure Monitor cheat sheet. This one's a three-parter, so let's jump into it. Azure Monitor's comprehensive solution for collecting, analyzing, and acting as telemetry for your cloud on-premise environments. And even though I don't have it in the slide here, it is an umbrella service, meaning there's a lot of things underneath this, and that's why we have 3 pages of information. It can create visual dashboards, smart alerts, automated actions, log monitoring, To obtain observability, you need to know metrics, logs, and traces. You can use them all together using them in isolate, but that does not give you observability. Metrics is a number that is measured over a period of time. Logs is a text file that contains event data, which was happening. And traces is a history of requests that travels through multiple apps and services so we can pinpoint performance or failures. Azure Monitor collects two fundamental types of data from sources, logs and metrics, which kind of matches up with our theoretical information here, right? So Azure Monitor Logs collects and organizes log and performance data for monitoring resources. Data logs are consolidated from different sources into workspaces, platform logs and Azure services, logs and performance data and virtual machine agents. Usage and performance data for applications can be consolidated in a workspace. You can be analyzed. They can be analyzed together using a sophisticated query language, which we'll talk about here in a moment, or review, I suppose. Work with log queries and their results interactively using log analytics. Azure Monitor Metrics collects, and that's the second part here, right? So the two fundamentals. Azure Monitor Metrics collects numeric data from monitored resources in a time series database. Metrics are numerical values collected at regular intervals and describe some aspects of a system at a particular time. Lightweight and capable of supporting near real-time scenarios, useful for alerting and fast detection of issues. You can analyze them interactively via the Metrics Explorer. On to page 2. Log Analytics is a tool in the Azure portal used to edit and run log queries with data in the Azure Monitor logs. Log Analytics is used a language called KQL. Log Analytics, I think that's Kusto, right? So Log Analytics workspace is a unique environment for the Monitor logs data. Each workspace has its own data repository and configuration. Data sources and solutions are configured to store in the workplace. And I really wish I put the word data lake in here. It's not important for the associate, but for other exams, it helps you understand if you think of it as a data lake. Azure Monitor Logs is based on the Azure Data Explorer, and log queries are written using the Kusto query language. KQL can be used in a log analytics, log alert rules, workbooks, Azure dashboards, and all over the place. Kusto is based on a relational database management system, so you'll see database tables and columns. Some query operations include calculated columns, searching and filtering on rows, group by, aggregates, join functions. If you're used to using SQL, you know what I'm talking about. Kusto queries execute in the context of some Kusto database that is attached to a Kusto cluster. Kusto is generally composed of the following entities: clusters, database tables, columns, functions. Let's talk about them quickly here. Clusters are entities that hold databases. Databases are named entities that hold tables and stored functions. Stored functions are named entities that allow reuse Kusto queries or query parts. Tables are named entities that hold data. Columns are named entities that hold scalar data types. And then you have external tables, which are identities that reference data stored outside the Kusto database. These both count as tables. That's why it's not in the list up here. But generally, these are pretty self-explanatory. Metric Explorers is a subservice of Azure Monitor that allows you to plot charts, visualize correlating trends, and investigate spikes and dips in the metrics values. To visualize a metric, you need to define the scope, the namespace, the metric, and the aggregation. We're on to the last page here. Alerts notify you when issues are found within your infrastructure or application. They allow you to address issues before the users or system notice them. Azure has 3 kinds of alerts: metrics, logs, and activity log alerts. Sorry. There is a diagram. If you remember our follow along, I actually break down all the structure of an alert. You should go review that. I didn't put in the cheat sheet because it just would have been too much here. Azure dashboards are a virtual workspace to quickly launch tasks for day-to-day operations and monitor resources. Azure workbooks provide a flexible canvas for data analysis and the creation of rich visual reports within the Azure portal. It tells, and just to highlight what Azure workbooks are for, it tells a story about the performance availability about your applications and services. Then we have application insights, and this is an application performance management, an APM service, and it is a subservice of Azure Monitor. That's why all these things are under Azure Monitor. Automatically detects performance anomalies, includes powerful analytics tools to help you diagnose issues, to understand what users do with your app, designed to help you continuously improve performance and usability. It works for apps on the .NET, Node.js, Java, Python, hosted on-premise, hybrid, and public cloud. Works everywhere, basically. Integrates with your DevOps processes, can monitor and analyze telemetry from mobile apps by integrating the Visual Studio App Center to use application Application Insights, you need to instrument your application. To instrument, you need to install the instrument package, SDK, or enable Application Insights using Application Insight agents when supported. Apps can be instrumented from anywhere. When you set up your Application Insights monitoring for your web app, you create an Application Insight resource in Azure Monitor. You open the resource in the Azure portal to in order to see and analyze telemetry collected from your app. And last, the resource is identified by the instrumentation key, the I key. So there you go. Hey, this is Andrew Brown from Exam Pro, and we are taking a look at Azure API Management. So this integrates existing backend services into modern API gateways. And this service, there's a lot to it, so we're going to be doing quite a bit here, maybe more than we have to, but it is a very powerful service, especially if you're trying to be a developer on Azure. So we're going to just make sure we spend a good amount of time with it. So it follows the API approach of decoupling the front-end and back-end teams with the help of API mocking. The Azure API Management handles the full management of your APIs. It centralizes the securing, versioning, documentation, and compliance from your backend services in a single endpoint. So very powerful tool, but let's get to it. So let's go over key concepts or key components of API management. I do not have a fancy visual for this. It's just very hard to visualize, but we will learn all this stuff as we go through it. So let's talk about what we have here. So we have an API that represents a set of operations. API operation, which connects an API endpoint to its backend. We have a product, which is a logical grouping of APIs. A single or group of APIs make up a product. So this is how your APIs are presented to developers. So it can either be public or private. We have a backend that represents backend services in your API. There are groups. These are used to manage the visibility of products to developers, such as administrators who have full access to the API management, developers who are users with access to the developer's portal with permissions to build applications, guests, users without access to the developer portal, but with the reading permissions in some services. There's the idea of developer. So this belongs to a product group, and each developer has a primary or secondary key to call that product's API. There are policies, configurations, and validations that are applied in progress to incoming requests and outcome responses, which you will see in closer detail in the upcoming slides. There are named values. So these are key value pairs used with policies. Values can be a result of an expression. There are gateways. So this is where your API calls and are received, and policies are applied to incoming requests. Then there's the developer portal. So this is where developers can access all the APIs and products listed by your APIM. Alongside the APIs, operations, documentation, developers can also request access to your APIs from the developer portal. But again, we'll figure this out as we go through it, okay? All right, let's take a look here at the Echo API service. So when you create APIM gateway, that's the first thing you'll do. You'll get by default this thing called Echo API. And I was like, whoa, what is this thing? I wasn't sure what it was. And I thought it was kind of interesting. That's why I expand upon it here, which I didn't really see much of it in the documentation. So I had to piece things together. But the idea is that Echo API provides a bunch of existing endpoints. And these are mocked endpoints to a non-production Azure service used to test Azure API management. So, you know, if you don't have an API yet, but you want to interact with it, it's going to go to the service called echoapi.cloudapp.net/API. And again, it's just a dummy application to test against. So that's what that is. So if you see it, you don't need it. You can absolutely delete it. But you always get one when you create a gateway, okay? All right, let's take a look at the feature comparison for APIM, because it's one of those services where there's a lot of features, but they're not always available to you depending on what plan, subscription, what kind of user you are. So let's take a look at how the features change based on what plan you're using. So across the top, we have consumption, developer, basic, standard, and premium. Red is what's not available for that particular plan. Green is what is. So for Azure AD, we do not have it for consumption or basic. For virtual network support, it's just not supported for consumption, basic, and standard. For multi-region deployment availability zones, we're only getting that for premium. For multiple custom domains, premium as well, and also for developer portal, the built-in cache, And built-in analytics are not available in the consumption plan. If you want a self-hosted gateway, it better be on the premium. Basically, almost developer always says yes because you have to play around with things, right? So TLS settings is for everyone, external cache is for everyone, client certificate authentication policies are for everyone, which is very generous. Back and restore, you're not going to get in the consumption model. And that's not all. We got a few more here. So if you want management over Git, Direct Management API, Azure Monitor Logs and Metrics, Static IP, or WebSockets API, you're not getting those in the consumption model. Now, Graph API, GraphQL API is available for all of them. So there you go. All right, let's take a look at API authentication. So in order to authenticate with our APIs, we configure those settings under our subscription setting. So it's as simple as doing a checkbox there. So if the subscription is required, only developers with a valid access key can use it. And so the idea here is we can configure where the API will receive those access keys, which can be sent as the header or query string. So there are some options there. If this thing is not checked, then that means anyone that is anonymous has requests will be allowed. So it's as simple as having that checkbox there and having a key. So there you go. All right, so let's take a look here at groups for APIM. So groups are used to manage the visibility of products to developers. And so we can break these down into some broad categories. We have administrators. So they manage API management service instances and create the API's operations and products that are used by developers. Then we have developers. They are authenticated for the developer portal. That users that build applications using your APIs. Developers are granted access to the developer portal and build applications that call the operations of an API. Then you have guests. So these are unauthenticated developer portal users, such as prospective customers visiting the developer portal. They can be granted certain read-only access, such as the ability to view APIs but not call them. So administrators can also create custom groups or use external groups in an associated Azure Active Directory tenant to give developers visibility and access to API products. A user can belong to more than one group. So there you go. All right, let's take a look here at front ends and back ends, starting with front ends. So front ends define the route or endpoint and the documentation configuration around that endpoint. So the idea here is we have front end and we have a single method here, which is post/resource. And if we were to open that up, you can see that we have, I'm just getting my pen tool out here, we have a description for our documentation, the display name, the name, I can't remember what the difference for the name is, but it's called create resource. We can set its URL, its method, and then down below we have additional parameters. So API does not host APIs, but it creates facades for your APIs. That's a key thing to remember. API, so API management, it does not host APIs. It's creating a facade for your APIs. So let's take a look at the backend. So for backends, you can set the following types. You can set a custom URL, so point to a server where your service is running. You can say to go to Azure Resources, integrate directly with a resource, such as Azure Functions, App Service, Container App, Logic App. I'm just missing the P there, but it's 2 Ps. So you have the idea up here where we can see custom URL, Azure Resource, Azure Service Fabric. Okay. We have some additional options here. So we can authorize credentials that present requests credentials to the backend service. There are options like headers. So that's HTTP headers. We can fetch from named values. We can query based on query string. You can fetch from named values there as well. You have control of client certificates, so X509 certificates, which we do talk about in this course, which are stored in Azure Key Vault, which is the section that we're talking about there. So you're just seeing those options, headers, queries, and client certificates. But yeah, there you go. All right, let's take a look here at policies for APIM. So API management policies allow you to change the behavior in multiple stages of your endpoint's request lifecycle. You can update any part of the request response message, such as the headers, bodies, URLs. And there are 4 areas where policies can be applied. We have inbound for incoming requests, backend before requests reach your backend, outbound before sending responses back to the client, and error when a request encounters an error. Just to kind of visualize it, we have our front end, incoming processing, back end, outbound processing. And so the idea is that here, for the inbound processing, that's where we have policies apply. That's the one they're talking about right here. And then we have for the backend, so before requests reach your backend, outbound processing, and then error is not visualized because it would be whenever an error would occur here, okay? Azure has a collection of policy groups which contain many policies you can apply, and we got a big list here. We have access restriction policies, advanced authentication, caching, cross-domain transformation, Dapper integration, validation policies, GraphQL. So there's a lot of great policies that we can already utilize. When an error occurs, no other policies are applied except the error policies. However, if other policies were in effect prior to the error, they will not be removed. Product level policies apply to all API operations within a product. So now let's go take a look at an example of a policy, okay? All right, let's take a quick look here at a policy example. So you're going to see this policy here, and we are doing it right on the Echo API. So this is for an outbound policy to cache the response in a GET operation. I believe that all those policies are in the documentation. You can easily copy and paste them in. We do a follow along for policies. That was something I definitely covered. I just don't remember if it was part of the system or, I mean, it must be because it says here retrieve resource cache. But anyway, the idea here is that this policy stuff is in an XML language. Not super important to learn what it is, but the fact is that there is a lot of available policies available for us, so we can pretty much copy paste and figure it out from there, if that is clear. And here is kind of another visualization that I just want to show you relating to our policies here, just because it kind of maps up my little graphic where we have the front end, the inbound processing, the outbound processing here. But if you notice here, it says policies. I know it's really small, but you can see it says base, cache lookup, rewrite URL, and here it says base, and then cache store. So the idea is you can see what policies are being applied there. So there you go. All right, so what we're going to do here is look at all the possible policy groups that are provided by Azure. And when I say policy groups, I mean the policies within those policy groups. So you get an idea of what kind of policies you can do to transform, manipulate, filter during transit of a request from a response through APIM. We're not going to look at all the code examples, but I'll pull out a couple per policy group here. We're starting with access restriction policy. So the first is check HTTP header, so enforce existence or value of HTTP header. Then we have limit call rate by subscription, so prevents API usage spikes by limiting call rate on a per prescription basis. That's pretty cool. When you look at other providers like AWS, where they have API Gateway, there is like a fixed limit on there. I don't remember there being any kind of policy to do that, so I like how you have the flexibility there to choose. Hopefully it's on there by default in that base. I don't know. Limit call rate by key, so prevent API usage spikes by limiting call rate on per key basis. Restrict caller IP. So filter, so allow or deny calls from specific API addresses or add an address range. That could prove very useful. Set usage quota by subscription, so allows you to enforce a renewable or lifetime call volume and or bandwidth quota on a per subscription basis. Set usage quota by key, so allows you to enforce a renewable or lifetime call volume and or bandwidth quota on a per key basis. Validate JWT, so enforces existence and validity of a JWT JavaScript web token, extracted from either a specified HTTP header or a specified query parameter. JWT is very common for authentication of client-side applications. Validate client certificate, so enforces that a certificate presented by a client to an API management instance matches specified validation rules and claims. Let's take a look at that restricted caller IP. Very, very simple. We define IP filter, we have an action, the IP address that is allowed in this case, or a range. So that one is, again, very simple. These are not hard to figure out. We have validate JWT. So there is some stuff there, and it is what it is. Okay. So we'll go on to advanced policies. So here we have control flows. So conditionally applies policy statements based on the evaluation of Bool expressions Forward request, so forwards the request to the backend service. Limit concurrency, so prevents enclosed policies from executing by more than the specified number of requests at a time. Log to event hub, so sends messages in the specified format to a message target defined by a logger entity. Emit metrics, so send custom metrics to application insights at execution. Mock response, so aborts pipeline execution and returns a mocked response directly to the caller. Retry, retries execution of the enclosed policy statements, and if and until the condition is met, execution will repeat at the specified time intervals and up to the specified retry count. Return response, so aborts pipeline execution and returns the specified response directly to the caller. Let's take a look at limit concurrency. That seems like a good one to have. So here we have an inbound, and then we define our backend. We set our limit concurrency. It's setting the forward request to a timeout of 120, so prevent enclosed policy from executing by more than the specified number of request time. We have mock response. That one would be very, very useful. Like you just want to, you don't want to have a real response. You just want to put whatever you want in there. So it gives it back a status 200 for application JSON. More advanced policies here. So send one-way request, send a request to a specified URL without waiting for a response. Send request, send a request to a specified URL. Send HTTP proxy, so allow you to route forward requests via HTTP proxy. Set variable, persist a value in a named context variable for later access. So here's an example of one where we're setting that variable. So we're saying, is it mobile? And we want to know, is it mobile? So the idea is it'll take that value from that agent, and then we'll have that variable available for us to determine, was the request mobile? We have wait, so wait for enclosed, send request, get value from cache, or control policies to complete before proceeding. Set request method, allow you to change the HTTP method for a request. Set status code, change the HTTP status code to the specified value. Trace, adds custom traces into the API inspector output, application insight telemetries, and resource logs. Looking at authentication policies, and I don't know why that's highlighting. Oh, I probably have a graphic above it, that's why. So we have authenticate with basic. So authenticate with basic service using basic authentication, very common for test environments. Authenticate with client certificate, so authenticate with a back-end service using a client certificate. Authenticate with managed identity, very popular use case for Azure services. So authenticate with a backend service using managed identity. So there's an example, basic auth. That's a username and password. You've probably seen it if you've ever gone to a site where they just give you kind of like an alert. You have to enter those two in. And for this one, you can see that it's going to Vault for the managed identity. Caching policies, so get from cache. Perform cache lookup and return a valid cache response when available. Probably a very popular policy to be used. Store to cache, cache response according to specified cache control configuration. Get value from cache, retrieve a cache item by key. Store value in cache, store an item in the cache by key. Remove value from cache, remove an item in the cache by key. So here, the example is obviously very big for get from cache, but here it says vary by developer, cache key lookup. So I guess you're giving it these things. Yeah, sometimes they're not always very clear when you're reading them, but that's fine. For cache store value, so store value, you provided a key. There is the value. The duration I'm assuming is how long it lives for, maybe the TTL. Cross-domain policies. So we allow cross-domain calls. This is something you probably really, really would want to enable, especially if you're building applications that are not on the same domain. So I could see people using this quite a bit. Makes the API accessible from Adobe Flash, Microsoft's Silverlight browser-based clients. Did not expect that as a description. CORS, I was thinking of CORS, that's why. Add cross-origin resource sharing, support to an operation or API, allow cross-domain calls. I feel like this one's going to happen a lot. I didn't know Microsoft Silverlight still existed. If people don't know, Silverlight is a competitor to Adobe Flash output. I guess Adobe Flash probably does HTML5 now. I'm just thinking of old Flash players. JSON-P adds JSON with padding, support to an operation for an API to allow cross-domain calls from JavaScript browser-based clients. So that is the cross-domain one, very simple. There's CORS, and if you've ever seen CORS, this looks the same. If you're on AWS, if you're anywhere else, it's the same XML. It looks the same. So it looks big, but it's not as scary, and you'll come across it quite often, especially with APIs. Transformation policies: convert JSON to XML, converts request to response bodies from JSON to XML, convert XML to JSON. You get it. Find or replace a string in a body, mask URL in the content, set backend service, set body. These are very clear. Set HTTP header, set query string parameter. If you want to read these, you can, but they're very straightforward. Rewrite URL. That's probably a very popular one, but maybe the example is too large, so I don't show it here. Transform XML and XSLT. Let's look at XML to JSON, because I thought that one was kind of interesting. So you say XML to JSON, and I guess it just turns it into JSON. HTTP header, something very common that you'll be doing. You can just set a header for whatever values you need to pass along. We have Dapper integration policies. So send request to a service, send message to pub subtopic, trigger output binding. There's an example of a trigger output binding. Validation policies, this is the last group. Validate content, validate parameters, validate headers, validate status code, validate GraphQL request. So we'll take a look at parameters. So here's an example where we have a parameter and it says prevent, detect, prevent, ignore. So I guess the idea is it's just saying, like, if those parameters are present, allow them. If not, ignore them. Validate status code. I figured this would be like a little bit more interesting, this one, but it's not. Status code, so prevent unspecified status code action. So do not allow it to have an unspecified code action. I didn't know that that's possible. I thought status codes are always returned, but I guess you learn something new every day. But those are all the policy groups, and hopefully you get an idea of policies you can apply, because that's the greatest power of APIM is those policies. Okay. All right, let's take a look at different ways we can define APIs within APIM. So the idea here is that you're ready to create an API. You have a gateway, you want to create an API. So you hit that add new API button. You got a bunch of options here. So you can define one manually via HTTP endpoints, WebSockets, GraphQL. Of course, that's going to vary what you want. WebSockets is great for real-time stuff. Maybe you're making a video game, maybe you're making a chat app. GraphQL is becoming a popular alternative to REST-based applications like standard endpoints. So GraphQL allows you to define a query to query data. Personally, it's not my favorite, but I like the fact that it's all rolled up under one API gateway in Azure. The next thing is we can define based on a schema standard for importing, defining APIs. We have Open API version 3, WADL, WSDL, and the latter two I don't know much about, and so